Hello, today we are going to learn the Java programming language by following the Java tutorial from docs.oracle.com/java.se/tutorial. Let's look first at what the Java programming language is. So the wiki article says that Java is a framework, a virtual machine, Java Virtual Machine JVM. There's bytecode.class files. There's Java source code, which is .java files. There's a Java standard libraries. There's a Java compiler, Java C. Hotspot is the virtual machine from Oracle. There's another one from IBM. Java 19 September 2022. First appeared May 1995. Okay, so .java is a source code file containing Java programming language. .class is a bytecode class. .jar might contain .class files, might contain source code files. It's related to the C# programming language. Is of the model write once, run anywhere. Strongly object-oriented programming in the C++ style of object-oriented programming, not in the sense of Smalltalk object-oriented programming. James Gosling, Sun Microsystems. OpenJDK effort. GPL2 only. Okay, so first of all, I will need the latest version of the Java virtual machine, of the Java compiler, of the Java framework. So let's try to find it out. I'm on Kubuntu 22.10. So Java download. So we might either download from Oracle or from openjdk.org. So it says Oracle's OpenJDK JDK binaries for Windows, macOS, and Linux. Okay, let's try that. So JDK java.net/19. Ready to use JDK 19, this thing. So JDK meaning the SDK, also contains a compiler. JRE meaning a runtime, does not contain the Java C compiler. I'm on Linux x64. I download the zip, the targz file, save. Okay, so what's the size? 195 megabytes compressed. Just a second. Okay, so we have downloaded the SDK for Java, which is called OpenJDK JDK 19.0.2 General Availability Release under the GNU General Public License with a class path exception. Okay. Let's extract this thing and see what's inside. tar-xzvf. This is how it looks like. We might put it into the .opt directory. Let's do that. Where's the .opt? Okay, good directory. Next, I'll need an IDE, Integrated Development Environment. Let's try to install IntelliJ IDEA Community. So I want tar-gz. Yes. Download. Save into the same directory. So this one is almost 1 gigabyte in size. 4 times the size of the Java Software Development Kit. So this is going to be an IDE, Integrated Development Environment. We will be able to edit .java source code files. We will be able to run, debug, step in to go to definition, watch, decompile, and other features that are available in Java integrated development environments. Okay. Let's see where we were with the tutorial. Let me open this in a new bring here. Let's start. So it says that this tutorial is for the version 8 of Java. And since there, the current version that I have downloaded is version 19. So there have been some language changes. Maybe we want to go over those language changes. No, thank you. We will continue with the tutorial. Okay, so there's lessons, examples, and grouped into what are called trails. We'll start with the first trail, which is basics. So the trail is called Getting Started. This one, an introduction to Java technology and lessons on installing Java development software and using it to create a simple program. All of these trails and the tutorial, you can buy it in book form. This thing, the Java tutorial, a short course on the basics, 6th edition, paperback. Okay, so let's go at getting started. Everything you need to know about getting started with the Java programming language. Java technology phenomenon. Java is a technology, a framework, a programming language, a platform, a virtual machine, many things. Okay. The Java technology. Let's increase the fonts a bit. Java programming language, object-oriented, similar to the C programming language. Multi-thread, it started with non-native threads, now it has native threads. Architecture neutral in the sense that the .class files are no arch, so they run just as well on Linux ARM64 as in Windows 32-bit. Portable, high performance. Okay. Source code is written in plain text files with the extension Java. Then there's a thing that's called the Java compiler, Java-C. Takes a file with extension.java, creates a file with extension.class. So for each and every class or enum or type that's defined in the .java file, it creates those .class files are in a format that's no arch, so it runs just as well on hundreds of CPU architectures, NDNSs, operating systems, etc. Because there's something that interprets these .class files, which is called the Java virtual machine. So the source files are compiled into .class by the Java-C compiler. .class files contain bytecodes, the language of the Java virtual machine. So the x86-64 CPU has its own assembler for 64-bit, 32-bit, etc. Well, this is similar. There's the Java virtual machine, which has its own, as it were, an assembly programming language, which is this bytecode, the machine language of the Java virtual machine. And there's the executable called Java that takes .class files, starts an instance of the Java virtual machine, and interprets all of those files. And then it does what it should do. So it writes things on the standard output. On the terminal, it shows graphical user interface windows. It runs the program. Okay, so there's source code, there's the running program, and this is not compiled to machine code as it were if the programming language would be C++ or C, but it's compiled to a no arch version. And then this is not interpreted using just the operating system and CPU, it's interpreted using the Java executable. Okay. So .class files run on many operating systems, many CPUs. Oracle.com, Sun Microsystems were pushing this their own operating system, which is called Solaris. So if I were you, I would ignore the parts where Oracle talks about Solaris. Okay, so it runs on Microsoft Windows, Linux, macOS, etc. Okay, so we have an example of a Java program. So it's hello world app.java, has this content, starts with class hello world app. So this is the definition of a type. In there we have public static void main string array args. So this is the entry point, similar to the main function in a C or C++ programming language. This is a function that's part of a type, so it's called a method, and a static method, so you don't need to create an instance, an object of type hello world app. You can go hello world app dot main. So this is a function of the type, not a function of the instance of a type, static method. And then it uses a standard library function, static method, which is called system.out.println, and as parameter we give it a string which is called hello world with a exclamation mark. And then there's the compiler, and then on different operating systems, different CPUs, different NDNS, different kernels, etc., you have the JVM installed. This is usually done by not installing the Java Software Development Kit on Java JDK, but installing the JRE Java runtime environment on the various operating systems. And all of the Linux operating systems, all of the Linux distributions have a Java runtime environment and a Java JDK available in their repositories as binary packages. Okay, for instance, in Ubuntu, we have the following packages. So, apt file, find javac. How do we find just javac? So there's OpenJDK 8 JDK headless, has the executable javac. What else? Let's search for a /bin/javac. Okay. So there's OpenJDK 11 JDK headless. The same thing for versions 17, 19, 18, 20, and 8. And so this is the thing that takes .java files and creates .class files, so the Java compiler, similar to CC, to GCC, to a C or C++ compiler. And then for the executable that hosts the Java virtual machine, so takes .class files and runs them, which is called Java. There's both JDK headless. Where are you? No, there's just JRE headless. So it has this Java, JRE headless, this thing. So 19, 20, 8, 11, 17, 18. Okay. But I did not install Java runtime environment or Java JDK from my Linux distribution from Kubuntu 22.10. Instead, I've downloaded the JDK, which JDK also contains a runtime environment. So I have both the Java executable that runs .class files and the javac executable that takes .java file, source code files and compiles them to .class files. So a JDK also contains a JRE. And I've downloaded the JDK, which is the bigger one, the one containing the other, because I also need the Java compiler. and I've downloaded from the official website from Oracle. Okay, I put it into tilde/.opt, and then the name of the thing that's inside this archive. Okay. Meanwhile, I've downloaded the IDEA IntelliJ IDEA IDE, the community edition version. So let's see how this thing, how can we install this thing? First of all, I'm going to uncompress it. So tar -xzvf and then IDEA. So I wrote I and pressed the tab key. It auto-completed the entire file name. So I go enter. So there's plugins for Android, plugins for Groovy, Gradle, for the Kotlin programming language. Let's see if it has a Java inside. So Ctrl S, Java C. It has a Java C, so it's jbr/bin/java C. Okay, what about a Java file? Yeah, in the same place, so jbr/bin/java. Okay, let's see how we are supposed to run this thing. Probably from the bin directory. It's going to be called idea.sh. Yeah, probably this one. So I'm going to install it in tilde/.opt. I'll copy this directory. And then I'll rename it to something shorter. Without the version. So idea minus uppercase I, uppercase C. Okay. So JBR is the Java SDK and runtime. So JDK and JRE. And many other things. Okay, so we go to tilde/.opt/idea-icbin. There's an idea.sh file. I double click on it. So it tries to load the project so that I have used this IDE before, so it has configuration files for my existing user. Where are those? .java. I know, .config. JetBrains, this thing. So let me close, delete this directory. Okay, and then .cache. Hopefully it's enough. Okay, let's start IDEA again, the ID, and says do not import settings, yes. Welcome to IntelliJ IDEA. Take a quick onboarding tour, yes. So this is the project view. We can expand the elements in the tree view. Double click a Java file, a file with extension .java. Okay. It says switch to the Learn tool to continue with the lesson. Okay, you can go with Alt-1 to the project view. IntelliJ cannot find the JDK on your computer. The IDE needs to run Java programs using the JDK. Click the highlighted Setup SDK link. Okay, let's click here. I say add an existing JDK, which is in here in how do we show hidden files? .opt and JDK. So it found the JDK file. It determined that is JDK version 19. It indexes JDK files. Okay, says you have opened the demo sample. Now let's run it. In the highlighted area of the toolbar, you can see popular running actions. Run or debug. For now, let's run, not debug. So Shift F10. This button. Okay, so it built. Then it ran the Java binary, the Java executable, which is the virtual machine, and it gave it as parameters one jar file which contains many .class files. Then it said listen to this on this port. How do we wrap lines? This thing. And then it says that the .class files will be inside of this demo project. There's a /out subdirectory, then a /production subdirectory, then the name of the project, Idea Learning Project. And in there's a class that has a main method, a static method, and that's going to be run. Okay, so this port 44909 is the part of the IntelliJ IDEA debugger and runs as part of our application. So our application has now a backdoor that's probably served over TCP localhost, and the IDE can communicate to our process via that backdoor. Okay, since we do not have any breakpoints and we did not start in the debugger, we just ran the executable, the resulting Java .class files. It executed the entire application and then it finished. So it says process finished with exit code 0. So this is the exit status of our application. And our application wrote to the standard output average all uppercase space of array space, then an array, then is 26.0, which is probably a float. Okay, and now it probably is going to teach us how to debug. So it says let's put a breakpoint on line 15. Okay, by clicking near the line number, it puts this red circle, which means that a breakpoint is enabled on line 15. Okay. Previously, we have pressed the run button, so run welcome.java shift F10. Now we're clicking on the debug welcome.java shift F9 button. Okay. If we press the run button, even though we have a breakpoint, the execution will not stop at line 15. We'll need to start our program not using run, but using debug in order for the breakpoints to be used. Okay. So now we're inside of the debugger. Our application has been compiled and started in the debugger mode. It saw that on line 15 of welcome.java there's a breakpoint, and when execution reached line 15, the execution stopped, all of the threads of our application are stopped, and we can inspect what's happening, how our application looks like in that instant. So how many threads it has on all threads, what are the call stacks, what method has called which other method, and we can inspect local variables, we can inspect member variables of all of the objects, and static members. Okay, so it says that the list of threads is I don't know which. This thing. So there's a main thread, there's a common cleaner thread, there's a finalizer thread, there's a notification thread, there's a reference handler thread, and then there's a signal dispatcher thread. We don't have source code on any of these threads, just on the first thread. We didn't create any threads, hopefully, during a Hello World sample tutorial application. Okay, so we're on the first thread, and the first thread has on line 15 we're inside the method findAverage, so it says findAverage line 15, and then this static method of the class welcome, so this function was called by somebody. By who? Let's find who can call this method. Find usages. So there's just one usage, which is on line 7 of the file welcome.java. In here, at the very end of line 7, at column 84, so this is line and column, the function findAverage is called with a parameter array, which array is a local variable of type array of int. So you take this local variable, you give it to findAverage, and then you call findAverage with a parameter array. Okay, findAverage is declared inside of the same class, so we can call it just by its name, no need to prefix it with anything. And then it's static, so both the caller, the function main, and the callee, function findAverage, are static methods, so they can call themselves with a simpler syntax, just the name of the method. Okay, this is the list of arguments or parameters, and there's just one, and this is called values, and values has received the whatever is inside of the array. So it has received 5, 6, 7, 8. In here we can see the inspect the parameter of the current method, which is called values. It's an int array, has 4 positions. So on the first position, which is position 0, indexes in arrays start with 0. There's a 5, then a 6, then a 7, then a 8. Okay, so the list of items inside of the array is shown in 4 places: here, 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 and here, and here, and who knows where else. Okay, let's close the find tool window, and now we need to go back to the debug tool window. So Alt 5 is debug. Okay, so this is called the list of threads within thread 1. This is called a call stack or frames, and the callee function find average was called by the caller function main. So the execution of our application started with the execution of main line 6. So this is where execution starts. Okay. And then line 6 is executed, then this complicated line is executed, but in order to actually print something to the standard output, this string needs to be computed. So it says string, then string concatenation. This function returns a string, then string concatenation with another string, and then string concatenation with whatever calling this method returns, which is a double. So this double gets converted to string in order for string concatenation operator to work. Okay. So where are we now? It says that we cannot stop or resume, so that means that we have accidentally stopped the debugger. So let's start the debugger again. Start. Now it stops at line 6, and we can use the buttons step over, step into, step out, or run to cursor. So we're going to get to line 15. How do we do that? We go step over such that it advances from line 6 to line 7. And now we need to step into such that it enters this function. If we go step over, it will go to line 8. But since we have a breakpoint, it will actually stop at line 15. So let's go step over to see where it stops. Okay, so it stopped at line 15 because it wanted to execute this whole thing at once and then go to line 8. But while executing the entire line 7, this thing calls this function, and when calling this function, lines 11, 12, 13, 14, 15 are executed. When line 15 was executed, there's a breakpoint there, so the debugger has stopped on line 15. So we're back to where we were, a call stack of 2 functions. This is the older function that was pushed on the stack, and this is the newer function that was pushed on the stack. Okay. Or we can step into, so we go step over to get from line 6 to line 7, and now we want to go from line 7 to line 11. The simplest way to do it is to put a breakpoint in here or to go run to cursor, but we're going to go the hard way, which is stepping into. So step into, says choose a method to step into with arrow keys. Okay. And it entered the only method that we have the source code to, because arrays.toString is a first party method, so it's from the Java runtime, the Java standard library. We don't have .java files for the JDK. We only have .class files for the JDK, and that's why it preferred not to step into here. And it stepped into our code, which we have the Java source code for it. So we have .java files for our code. We don't have .java files for external code, so for code from JDK, JRE, IntelliJ IDEA, etc. Okay. And now, since we're on line 11, we don't need to step into, we can step over. So not step into F7, but step over to advance to the next line. So we're on line 11, step over F8 will go to line 12. Step over F8 will go to line 13. And then it will go to line 14. No, it will go to line 12. So this is what's called a loop. A for each, a while, a repeat. So these are ways of running lines 13 more than once. Okay, so let's go step over and see how it goes. So there's a counter variable which is called I, which goes from 0 to values.length, which values.length is 4, and I should be less than 4, so I goes in fact from 0 to 3, 0, 1, 2, 3, which are actually the indexes of this array, because the first element in the array is on position 0. So 5 is on position 0, and I takes the value 0. Then I takes the value 1, and that's on index 1 in this array, there's 6. And then I goes to 2. On index 2 in this array, there's a 7, goes to 3, I equals 3, values of 3 is 8, and then it never gets to 4, because it says I should be less than 4. By hovering onto length, we can see that its value is 4. By hovering onto result, we can see the current value of result. So we can inspect all of the identifiers, all of the variables, parameters, member data, etc. by hovering on it while we're inside the debugger, while we're stopped inside the debugger. Okay. So I goes from 0 to 3, and it goes values of I, which means values of 0, values of 1, values of 2, values of 3, which means 5, 6, 7, or 8. And this operator is a unary operator, which is a sugar syntactics over this operation. Okay, so it takes the previous version of result, which is 0, and adds to it values of 1, which is 5. So it goes 0 plus 5, that's 5, and then it assigns the value 5 inside of this variable that's double, so it has floating point. It has a dot, so there's the integer part, and there's dot, and then there's the decimal part. Okay, so now result is 5. Then I is still 0. I is being incremented to 1, 1 is less than 4, and then it goes values of 1, which is 6. So it goes the previous version of result, which is 5, plus values of 1, which is 6, so it goes, this thing is 11, so it assigns to result the value 11. Then I is incremented, becomes 2, 2 is less than 4, values of 2 is 5, so 11 plus 5, that's 16, and 16 is assigned to result. Let's actually do that. Let's actually see how these increments work. Okay, let's put a breakpoint here, this thing. Delete the breakpoint on line 6. By clicking on the breakpoint, you delete a breakpoint. Okay, we stop the debugger with stop welcome control 2. We start the debugger with debug shift F9. Okay, and then we'll go just step over. So result is 0, values is 5 to 8, I is 0, result is 0, values of 0 is 5, result plus 5 is 0, plus 5 is 5, and 5 will be assigned to result. 5 is integer, and no, it's not an integer because result is a double, is in fact 0.0, not 0. So this is a double plus an integer, so the result is actually a double, which is 5.0, so 5.0 will be assigned to result. Okay, now result is 5.0. Okay, I is still 0, then the next instruction to be executed is this thing, which is the post increment of I. So this is equivalent to I equals I plus 1. I will be incremented, will become plus 1, which is 0 plus 1 will become 1. Okay, so I is now 1. I was less than 4. If I is not less than 4, this part will not be executed anymore, and the next line to be executed is 15, which is after the for block, the loop block. Okay. So now I is 1, values of 1 is 6, and 5.0 double plus 6 integer is 11.0. That will be assigned to result. And now its result is 11.0. Okay, next I will be incremented. I is 1, it will go I equals I plus 1. I plus 1 is 1 plus 1, which is 2. 2 will be assigned to I, so I will be 2. Okay, then it goes values of 2 is 7, result is 11.0, so that will be 18.0. And 18.0 will be assigned to the local variable, this thing of type double called result. I is still 2, I will be incremented, will become 3. 3 is less than values.length, which is the number of elements inside of the array values, which is 4. So this is true. I is now 3, values of 3 is the last one, which is 0, 1, 2, 3. So the last index inside of the array values is 3, the biggest one, and the values of 3 is 8. So values of I is 8, result is 18.0 plus 8, that's 26.0. That will be assigned to result. Step over. Now result is 26.0. I is still 3. It goes I++, which is the same as I equals I plus 1. I plus 1 is 3 plus 1, which is 4. I is being assigned the value 4. 4 is not strictly less than 4. And then it will jump straight to line 15. Okay. Result has stayed unchanged to 26.0. And now it is going to return the result. So it, instead of doing a find average, it does a find sum. So it computes the sum of all of the integers in the array. If you go step over, it will go to line 16. Not really. It goes to the caller of the function find average. In here, it still needs to compute the string concatenation of 4 elements, so a string, a string, a string, and a double. We go step over, and the concatenation was successful, no exception was thrown. This resulting string from the concatenation was actually written to the standard output, which is this thing, console. So the debug Alt5 tool window, and in there's a tab console. In here we can see what it wrote. So it wrote average of array space, then it printed the array. So those square parentheses, 5, 6, 7, 8. And then it goes space, is, and then space. And then the double converted to string, so 26.0. Okay. And now we're at the last line, which is line 8. Back to debugger, and we can see that the core stack now contains just one function, which is main line 8, this thing. And in here we have visible just args, this parameter argument to the function. This thing, it has the icon P, it says it's a parameter. And then there's a local file, a local variable, which is this array, which we can inspect. There's no other variable or parameter or argument that can be, that is accessible to the debugger, so we cannot see it. Step over, finishes execution. So after the final line, which is line 8, our executable exits and returns the exit status success, exit code 0. Why? Because the function main doesn't return the type int. If it returns void, then it always, our executable always exits with exit status 0. Okay. We're inside the onboarding tour, and it does not like the fact that we edit the source code. So let's see if just like this is enough to go back. Yeah, so it saw that now the source code is identical to the original source code. And it says that the debug tool window provides toolbars with various debugging actions. We can follow the tutorial debug workflow later. Okay. Now it says Let's stop the debugger. I've already stopped the debugger. I've restarted the onboarding tour. So it says that there's the debug tool window with toolbar with various debug actions. There's a debug workflow lesson that we can use later. So we got it. And says, let's stop debugging. Click the red square icon. Click the icon to stop debugging. Stop welcome, Control 2. Once you have discovered the problem in the code, I have, so it just sums, it never divides by the count of items. Let's fix it. Divide the resulting sum by the length of the values. The lesson script inserts /.values. Now let's type a dot to show all available completion options. So this is auto-completion dot. You can start typing length to reduce the completion list. And then press enter. You can press Ctrl space if you didn't press a dot. So if you press dot, it will also automatically show auto-completions. If it doesn't automatically show auto-completions, there's Ctrl space that shows completions kind of everywhere. Okay, so I can go LE. So now the auto-completions list is way shorter. The item is already selected, so I probably don't even need to select it, but let's do that. And then I press enter. Okay. You have just fixed a bug, but you can make this code look even better. IDEA, the IntelliJ IDEA IDE, highlights and adds a yellow bulb to the code lines that can be improved. So line 12 can be improved. Press Alt-Enter to preview the warnings and apply a quick fix. Let's do that. Alt-Enter. Says apply the first item, replace with enhanced for. So it replaces a for with a for each. Okay. How do I do that? Apply the first item. I need to press one. Enter. Okay. Then it shows intentions to save your time and make codings easier. Let's use an intention to reformat string concatenation. So press Alt Enter again to do another fix. It says replace string concatenation plus with formatted. So I need to go down, down, and down arrow key twice and then press enter. And it goes system out print instead of system out print line. And there's average, %s, %s, and then %n. Who knows what %n is? While working in IntelliJ IDEA, you might want to search for files in your project, symbols, classes, or even ID actions. Let's search for the toggle case action to make the average string lowercase. Press Shift 2 times to open search everywhere. Shift, Shift. Average has been automatically copied into the input string. Let's type case. So I wrote lowercase case and has offered me the option of touch bar match case, toggle case Ctrl-Shift-U, so I need to go there, down arrow key and enter. The case has been changed. Congratulations, you have completed the onboarding tour. You can close the learning project and return to the welcome screen or show more lessons. Okay, congratulations. Close the demo project. Press enter. And I'm back to the welcome screen. I'll close the take a quick onboarding tour and start a new project. So it has selected the correct OpenJDK 19.0.2. I want the source code to be in my current directory, in the today's directory. Okay. The name, it's okay if I go with untitled. No Git, language Java, build system, okay. Add sample code. Let's see what this does. If not, we'll create another project where we don't add sample code. Create. So it only added the hello world source code. Okay. Now let's put work on the left hand side of the screen, on the left half of the screen. Work being the IDE, where we actually write source code, and doc being the documentation that we're following right now. Okay, so let's see if we can create this source code file. So it says hello world app.java. How do we rename this thing? Hello world app. Okay. So now both the class is named hello world app and the file, the source code file, is named hello world app.java, the same capitalization. Then we have, what's here? So we have public class hello world app. What if we don't put public? It complains that what? No, it doesn't say anything. Okay. Then we go public static void main, lowercase main. String is a type with this capitalization, so uppercase S. Okay. String class represents character strings. And then args. And then open curly bracket. System out print line hello world exclamation mark uppercase W and semicolon. Okay, so this is the classical Java programming language hello world. Let's save this thing, Control S, probably. File, save all, Control S, correct. Let's have a trailing new line, so a line 6, which is empty. So there's a Java platform. A platform is the hardware or software in which a program runs. So there's Windows, Linux, Mac OS. A combination of operating system plus hardware. The Java platform is different from most other platforms in the sense that it doesn't contain hardware. It's software only platform that runs on top of other platforms. Okay, the Java platform has two components, the Java virtual machine JVM and the Java application programming interface. So this would be the standard library in Java. This thing, system.out.println. Okay, so we have been introduced to the JVM, Java Virtual Machine. Has been ported onto various hardware-based platforms, so combination of operating system and CPU and hardware. Central processing unit. So CPU is a central processing unit, is the processor. The other hardware would be a motherboard, a random access memory, and storage such as a hard disk or a SSD. The API is a large collection of ready-made software components that provide many useful capabilities. So let's see what that looks like. So I pressed the Control key on my keyboard and clicked on print line. So this takes me to the definition of the printline function. So we have both the signature of the function and the body of the function. So that exists in tilde/.op/jdk/lib, and then there's a thing which is called src.zip. So there's a zip file with all of the .java files from JDK. So the JDK is a collection of .java files that, using another JDK, are compiled to .class files. So all of those Java files have been compressed to a zip archive called src.zip. It's available on my machine. And when I tell the IDE to navigate to the definition and body of the method println, it actually unzips the src.zip file and takes me to the correct .java file. So control click. Okay. So it has these things which are called doc strings, documentation strings, and has this signature. So it's public, it's not static. How is it not static? It's not static. Interesting. And then the name is println and has many overloads. So could be called with an object, could be called with a string, could be called with an array of chars, which would be a string. Could be called with a double, with a float. So this float and double are numbers with a dot, with a decimal. Long, which is an integer. Int, which is an integer. Char, which is a character. So just one element from a string. There's also the type boolean with lowercase b. The only one with uppercase is string and object in the overloads of the println method. Okay. So control click on println takes us to the correct place, and it says that this is a function, that's a method, that's not static, that's member of a object which is called printstream. And printstream is a public class that extends these classes and interfaces. How do we go back? Navigate back, Control Alt left. Okay. left. And it has a body which we do not comprehend. I don't know what it does, this body. Okay, it says, the documentation says prints the value of x, which is the argument of type string, and then it also prints a new line terminator. So new line terminators being \n in most operating systems and \r\n on Windows. The same as invoking print of string, which does not put a line terminator, and then print line with 0 parameters, 0 arguments, which just prints the new line. So print of x and then new line. Okay. Print ln, there's an override, an overload, whatever, that has 0 parameters and that just prints new line. And control click on new line takes us to the implementation of new line, which, what does it do? Does text out dot new line, which actually does write to standard output the line separator, which in Java there are no properties. So this is a getter which actually gets the private static string line separator, which is platform specific, I'm going to guess. So \n everywhere, and on Windows it's \r\n, and it says this thing in the documentation. Okay, back to hello world app.java. So this is part of what's called in here the Java API, Java Application Programming Interface. This print line thing, this out thing, this system thing. Let's go to the definition of string. So string is a class that's defined in string.java. Out is a what? I don't know what it is. So system is in fact not a namespace, but a class. Interesting, super interesting. And the actual namespace is java.lang. Fundamental to the design of the Java programming language, the most important class is object, class, Boolean character with uppercase, to represent a primitive type as an object, so for boxing, an object of type uppercase D double contains a field whose type is double. There is a void class, holds a reference to a class object representing the type void. There's the class math, class is string, string buffer, string builder, class loader, process, process builder, runtime, security, and system. Throwable, throw, character encoding. Okay, so I guess that java.lang namespace or package name is so fundamental that you don't need to import it. Good guess. And then system is in fact a class. And if you have the name of the class, you can call, when you go the name of the class dot something, it allows you as auto-completion all of the static members of that class. So could be static data members or static methods. And out is a static field, which is a data member. R is a field, which is a data member. And in, out, R, in are the three standard Unix and Windows and generally C programming language standard streams. So std_out, std_in, and std_r. Then there are static methods: console, line separator, clear property, current milis, get environment, which returns all of the environment variables, get the environment variable with a given name, nanotime, exit, which makes the current process stop and returns the given status as exit status. And that's it. Okay. So we're actually calling system.out. Again, system is a class. Out is a static member variable of the system class. In here somewhere this out member variable is being initialized. How do I select whole world and match case? Okay, this is the first occurrence. Set out 0. And the system.out has the members. So there's print line with overrides. I can sort by name. Let's look at write lines. Print lines. Okay, so print line nothing, just prints the new line terminator, which is platform specific. Prints an integer, then a new line, the first character in a string, and then in a new line a longer integer, a number with decimal part. Okay. So now using the IDE, we can navigate to any symbol from the Java API. We can navigate to system, control, whatever. Navigate to out and navigate to print line. We can see the documentation of each and every one of them. We can see their signature, then implementation. So the API is grouped into libraries, classes, interfaces, packages. So system is in the package java.lang. Out is in Java package.java.lang. Print line is in the package java.io. Okay, so there's a hardware-based platform, which is a combination of operating system plus hardware. There's a Java platform, which consists of the Java virtual machine, so Java executable file, executable that's named Java. API, which is functions, methods, classes, packages, etc. Insulate the program from the underlying hardware. So the program does not communicate with the hardware, communicates with this Java platform. Can be a bit slower than native code. This is almost questionable, so it's really fast. Java Virtual Machine, JVM. Virtual Machine for the Java platform. Okay, next. What can Java technology do? It's a general purpose, high-level programming language. There's development tools. There's compiling Java-C, running Java. There's a debugger. There's JavaDoc for documentation. Java-C compiler, Java launcher, JavaDoc documentation tool. API. Core functionality of the Java programming language. Wide array of useful classes, objects, networking, security, XML, database, graphical user interface, threading, locking, containers. The core API is very large. So the JRE, the Java runtime, is contained inside of the JDK, the Java Development Software Kit. There's the Java hotspot virtual machine at the base, and then the rest are libraries. And on top of it, there's the files with extension Java, which is the Java source code. Java executable, Java-C executable, JavaDoc executable. Security, web services, JavaFX is for graphical user interfaces, the same, so Swing, Java 2D, Auth is also for graphical user interfaces, JDBC is for databases, okay, what else do we have? XML, calling, you can from Java call C as shared objects, or in Windows DLL files, or in macOS dylib, so you can open dynamic load libraries, although the exports from that dynamic library are C-style symbols, so the symbols as they were exported from the C programming language, so usually functions. You can call those exported symbols from the Java virtual machine using a variety of technologies, such as JNI. There's also JNE. Okay. Daytime networking, there's HTTPS, there's serialization, input, output, math, so you can compute the square root, compression, concurrency, regular expressions, etc. I have never used Java in the context of serving class files through the web browser via Java Web Start or the Java plugin. So we'll always skip such technologies. GUI, the standard used to be Swing, and the APIs that are below it, so Java 2D Auth, and the newer arrival is JavaFX. Okay, next. How will Java technology change my life? It truly is easy to learn once you know C, the C programming language, which is the simplest programming language, plus the pointers, right? You know C++, the C programming language plus how to use pointer in C, then you will not have much to learn to get into Java development. Okay, it says in here. Write less code, so probably compared to the C programming language, you don't need to create a ton of boilerplate code to. In the C programming language, you need to mimic the object-oriented programming, for instance, using the GNOME, GTK, glib, gobject library, whereas objects are native in C++ and in Java. Programs written in Java can be 4 times smaller than the same program written in C++. So there's a native string type in Java, which is really, really good compared to the situation with many string types in C++. Write better code. Automatic garbage collection helps you avoid memory leaks. Does not avoid memory leaks, but helps you avoid such things. There's many third-party libraries, like a huge number of third-party libraries. Many developers. Many online resources such as forums and Stack Overflow, and any question that you might ask has already been asked 10 times before and answered on the internet. Write once, run anywhere. WORA. They run consistently on any Java platform. We don't use Java Web Start. The Hello World application. How to compile a simple Hello World application. Oracle used to have its own IDE for Java, an open source IDE framework called NetBeans. Okay, let's go through all of these. So I have the software development kit, so JDK installed. I have an IDE, not NetBeans, but IntelliJ IDEA. I've created my application. It's called Hello World app. Displays Hello World. Okay. The IDE compiles the .java file to a .class file for me. By clicking on the run button, it calls the Java executable named Java with the correct command line. Okay. We should always use packages. In this sample, there's no packages. The class should be public, probably. If it's not public, it probably has a package level visibility. I've added the JDK to the IDE. Comments might start with // comments out the rest of the line. Might be multi-line. This is a docstring with a slash asterisk asterisk, then asterisk on each line, and then ends with asterisk slash. Everything is case sensitive, so we should expect that the source code is case sensitive, the executables, the command lines are case sensitive, everything. And in Linux and macOS, everything is already case sensitive. If you don't have a case insensitive partition in macOS. Okay, the docstring, the documentation for the args parameter. Let's put this code there. Control S. Says does not correspond to the file path. Okay. So it created under the src directory a subdirectory especially for the package. So the same name, hello world app lowercase. Okay. By clicking on the green triangle button, we can start without debugging or start with the debugging this method or this class. If we hover over args, now args has docstrings, has documentation, so the documentation will be shown. It says args minus the command line arguments, so whatever we wrote here. The same for the hello world app. It says the hello world app class implements an application that simply prints hello world to the standard output, and this is the string. Okay. Middle click with your mouse to close a tab. To compile, run build project. This is the build tool window. It says Java-C was used to compile Java sources. Doesn't say what command line executables have been run. Command line commands. Okay. So in NetBeans it creates a dist directory, and there it creates a hello world app .jar file. and then it starts java -jar and the output jar. Okay. The bytecode hello world app.class is generated. How do we see that? How do we show the properties of this file? Okay, so this is hello world app.class at the same level as the src directory. So in the top level of the project, there's a src directory with files with extension .java, and then there's a directory out with the subdirectory production, then the subdirectory, the name of the project, and then the rest of subdirectories that exist under src. So hello world app for the hello world app package, and then for the class hello world, it creates a hello world app.class file. If I try to open it, double click on it, it tells me that this is not a Java file, so it's not, the ID is not just going to open it. It's a .class file, which is a compiled file. The ID has a decompiler that can convert from the .class file back to a .java file, and in here it asks me if I want to do that. Let's say yes. And this shows me a totally different thing. So this is the input source code file. This gets compiled to hello world app.class, and when we decompile hello world app.class back to a hello world app.java, to a source code file, this is the result. Okay, so there's no this comment, this comments at the start of the source code file. It knows the name of the package because the name of the package is exposed from the .class file. It knows the name of the class. It knows that it's a class and its visibility, that is public. It doesn't know its docstring because it's a comment and gets stripped out by the compiler and ignored. Then it knows that it has a constructor, the default constructor, which is public, the name of the application, of the name of the class, no arguments in the parentheses, and no body. And then there's another public method exposed from the hello world app class, which is public static void main string array arg. So this is the signature. It knows how to reconstruct the signature from the .class file. And then the body is system out println hello world. Does not know about this comment because javac, the executable name javac, takes this file. The first thing that it does, it removes all of the comments. So this is a comment, this is a comment, this is a comment, and this is a comment. It also takes out all of the empty lines, such as these two, 21 and 13. Then it compiles to a .class file, and then using the IntelliJ IDEA ID, we have decompiled. Okay, so again, steps: hello world app.java is source code. Then the executable name javac converts it to hello world app.class. which we can look at if we want. So untitled, all production, hello world app, and then this is the file with the extension class, and it looks like this. It's a binary thing. Starts with cafe. So it has the starting bits in such a way that we know that it's a .class file. Let's see what file thinks of it. So says file space the name of the .class file. Says hello world app.class is a compiled Java class data version 63.0. Okay, we can see Java lang object, we can see Java lang system, we can see out, Java IO print stream, the string hello world in UTF-8, or what is this thing? Java IO print stream, print line, Java lang string. This is the name of the package, this is the name of the class. There's a line number table, code, local variable table. There's the main function, main method. There's a Java lang string, so the string class is from the package java.lang. There's an args variable parameter in the main method. There's a source file named java world app hello world app.java. Okay, so Java-C converts from this to this, and from this to this. It was a tool provided by the Integrated Development Environment, IntelliJ IDEA Community Edition. Okay, back to our documentation. Run the program. There's a button for that. So in here is the command line that runs the executable named Java, which is the virtual machine. If we give it enough parameters such that it starts the correct thing, which is it should start this method, not something else. So in here it says hello world app, which is the namespace, dot hello world app with uppercase H, W, and A, which is the name of the class. And this is the command line, and then this is the standard output, standard error from our program, which is hello space world. And then it writes a new line in here because we told it to. We said print line. How do we print without a line? Okay, so now it did not put a new line. So that's why we don't have an empty new line here. Now there will be an empty new line between hello world and process finished. This empty new line between hello world and process finished, because print line just prints whatever you tell it to, which is these characters on standard output, and then it does the equivalent of a print line without any parameters, which means advance to the next line using by printing the new line, terminator, string, depending on your platform. So mine is Linux. We can have more than one .java file. We can run an individual file. Okay, so there's code completion, refactor rename. Do we have such a thing? Refactor rename. We do. Okay, how do we run this thing now? We don't have the possibility of running it anymore. There's no green buttons to run this thing. Main method not found in class hello world app, which is the name of the package, hello world app, which is the name of the class. Please define the main method as public static void main string array args. Okay, next. For Microsoft Windows, you need to download the JDK. It's an executable. You install it, it appears in AdRemove programs. So let's do this example with Java-C to see exactly what's happening. Sure you want to exit? Yes. So we create a new directory, which is called what? Hello command line, like this. And it says create a source file, then compile it using Java-C, then run it. So we create a file named like this, Ctrl-C, Shift F4, Ctrl-V. It opened with the default text editor in Kubuntu, which is great for me. Okay. We paste this block. We put a trailing new line, Ctrl-S. This is a, what's this? Space character. Okay. Ctrl-S. So this is a docstring for the class. This is the entry point of the executable method. This is a comment, and this is printing to the command line hello world exclamation mark and then a new line. I've saved it. It's not ANSI. Should not be either ISG or UTF-8, which is default on Linux. Now we need the command line. We'll have it. And then we need to navigate there. We're already navigated there. And in here we need to run Java-C. So Java-C is from here. Bin Java-C, this thing. Okay, let's add to the environment variable path this directory. Ctrl-C. Echo $sign path. Okay. Path equals Control Shift V colon $sign path. Okay, so I have prepended to the path environment variable the directory where javac is. So now instead of saying tilde slash dot op slash jdk slash bin slash javac, we can put just the name of the executable and it will find it. So which javac finds it in the wrong place because it has 2 slashes. Okay, how do we revert what we did? Control Shift C, Control N, Control V, delete this extra slash, copy, path equals Control Shift V. And now path does not have a trailing slash after bin, and which javac does not have 2 slashes in here. Okay, so it says javac and then the name of the Java file. F2, it says it has a leading space, so the name of the file was wrong. Okay. Okay, so I went javac space, uppercase H, and then tab. It auto-completed the rest of the file name. Now I'm going to press enter. And it says illegal characters everywhere. What is this thing? Let's go Control Shift V. No. How do we copy without those 00 zeros? And BSPs. Okay, how do we copy correctly? We can't because of the NBSPs, the non-breakable breaking spaces. Okay, so we need to replace this character, Control R with a space, replace all, Control S, and now I pressed the upper arrow key in the terminal. It put on the command line the previous command line, which is javac space hello world app.java. I'm going to press enter, and this time it succeeds. Okay. If I go ls to list what's happening in here, there's a hello world app.java, which is the source code file. It's human readable in the Java programming language. And then there's the whole hello world app.class, which is readable only by the JVM, Java Virtual Machine, is bytecode. It contains a ton of zeros. Okay. we have a .class file. Now we can run our program. So our program consists of just one .java file, therefore, and inside there's just one class, just one type defined by me, and therefore just one .class file will be created, and I can run the program like this. So java -cp dot hello world app. So let's see what this command line actually does. Says option main class arguments. So we didn't give it, just a second. Control A, Control V. So Java, which is the name of the executable that will contain the JVM, Java Virtual Machine. You can give it as parameter a main class. So the class that will contain the method static, public, main, void, and then array of strings args as parameter. And then as options, it has these options -cp and then dot. There's no jars involved, so I cannot go java -jar and then the jar file. We're not using modules. Overview of Java options. It does this by starting the virtual machine, loading the specified class, this thing, the entry point class. It finds its main static method, which should have a signature like this. So it has even the possibility of starting a source code file, so a file with extension Java directly. Okay. So Java -cp and then this memory thing. This is probably class path, the class path parameter, and dot is probably the directory where we are currently, so the current directory. To find out the current directory, in Linux there's the command line pwd. Okay, so let me just search by cp, by -cp. So -class -path, or -class path, or -cp, and then a class path. There's a semicolon, separated list of directories, so dot is the current directory. Then we might have a semicolon, then a jar file, or a zip, the name of a zip file, or the name of another directory. But the current directory is enough because it's going to look for all of the files with the extension class in the class path, which is just the current directory. It's going to find the only one, which is hello world app.class. It's going to search inside the main class named hello world app. It's going to find it. It's going to find its method main, and it's going to execute that. Okay. Okay. So in order not to look at the manual page in the command line and to look at the manual page in a text file, I took the standard output from the command man Java and I placed that in the file a.txt. So I did not do append, which is greater than. I did rewrite, which is just greater than. And this is how the text file looks like. And in here, it's easier for us to search what we wanted to search, which is what does -cp mean. So -cp here, -cp class path, a semicolon path, separated list of directories. So similar to the path environment variable in Windows or in Linux. There's a path not just of directories, but could also be jar files, or zip archives. There might be a class path environment variable, but by specifying to the Java executable via the parameter -cp class path, that will take precedence over the environment variable class path. If you don't specify any class path, then the class path will consist of the current directory. So -cp dot is not really needed. Let's see that. And it works. Okay. What about .java? So it takes a bit more time. First it compiles, then it runs. You can see there's 2 seconds there, so 1, 2, 1, 2 versus just Java hello world app. It's less than a second. Okay. What do we do next? So we have run the application. The text was printed. A new line was printed. The program works. Next. Hello world for Linux. I have downloaded the linux-gz file for the JDK, not the JRE. I have used the text editor Kate. We could use Emacs if we want, or Nano. Whoa, what a terminal command. Control O, Control X. Okay, so this is teaching us how to use Pico, which probably these instructions will be very similar for the Nano text editor that exists in Ubuntu and in other Linux operating systems. Then again Java C, and then Java without any CP and -cp and dot, because they're implicit and default. Next. So let's look closer at the Hello World application. Here is the code again. There's source code comments, this part. There's a class definition and a main method. So documentation docstrings start with / asterisk, whereas / is just a possibly multi-line comment. So this is a comment. This docstring is also a comment, but because it starts with / to asterisks, is considered by the Java doc executable. Doc comment for short. So there's a separate tool, so Java C just ignores any comments, but then the tool Java doc, which is an executable, if it sees such type of comments, it knows that they are special, they are doc comments, and will generate documentation for the, in this case, it will say that this class has this documentation. Okay, so this single line comment / starts in here on this column and ends at the end of the line. If you want to comment just parts of the line, then you're forced to use this syntax. If you want multi-line, either start all of the lines with / or use this syntax. So class name, this is the declaration of a type. This is the type's name, and this is what type of type is it. So it's a class, not a struct, not an no. Okay, there's curly brackets for the body of the class. The main method is the entry point of the application. If the application doesn't have an entry point, Java will compile or will complain that there is no such thing, and it will tell you to add such a method, as we saw previously. Every application must contain a main method with this signature. You can either write public static or static public. The convention is to use public static. The name of the argument is not part of the signature of the function, so you can name the argument however you want. So similar to the main method in C and C++. And to put values in here, you use the last parameter for the Java executable. So you call Java executable with options, then a main class, and at the very last is a variable list of arguments. And since it's enclosed in square brackets, it might be missing. It might be 1, or there might be any number. And even if you open a .class file or a jar file or a .java file, it still has on the last position the Java command line the possibility of getting command line arguments to be put inside of the application's main function args parameter. Okay, so Java, then the name of the class, and then parameters. Each string in the array is called the command line argument. So this one. Okay, you might have a parameter, an argument minus descending to sort descending. Otherwise, you might sort ascending if your application sorts. Maybe your application reads from standard input 10 numbers, and then it prints to standard output the numbers in sorted ascending order. But if via args you receive the string minus descending, then you will print them in descending order. So there is a system class, as we saw. There's an out static member, data member of the system class, and then there's the print line method that both writes print, both writes hello space world exclamation mark to the command line, and then it does the ln part, which is it writes a new line separator. Okay. Getting started exercises. When you compile a program written in the Java programming language, the compiler converts the human readable source file into platform independent code that the Java virtual machine can understand. What is this platform independent code called? So it's called bytecode. Which of the following is not a valid comment? Valid comment, even a doc comment. Valid comment, invalid comment because it does not end, and then single line comment valid. So C is not valid. Question 3, what is the first thing you should check if you see the following error at runtime? Exception in thread main, Java lang node class def found error, hello world app.java. So either there exists a hello world app.class file which maybe the hello world app.class file does not exist. Maybe there's no hello world app class defined inside the hello world app Java if you start Java with the Java executable with a hello world app.java command line. So it first compiles from Java source code to class and then it runs the class. Or maybe the source code class exists, maybe the bytecode class hello world class exists, hello world app class exists, but maybe that class does not have defined the entry point main public static method. What is the correct signature of the main methods? Public static void main round parentheses string pair of square brackets and then args. When declaring the main method, which modifier must come first, public or static? Does not matter. What parameters does the main method define? Just one, an array of string. Does not matter how you name it. Change the hello world app Java program so that it displays Hola Mundo. Okay, let's do that. Okay, so we have the class file, which is the bytecode. We can always delete it because it's created by javac, the Java compiler, whereas we'll never edit the .java source code file. So that was called a build artifact, the class file, whereas the .java file is called the source code file. Okay, so it needs to say Hola mundo. But that's invalid because it should start with an inverted exclamation mark. Hola mundo. Ctrl S, and then we compile either in just one step, like this. So with just one command line, we both compile from .java to .class and then we execute the .class. Or in two steps, first we compile, where are you? javac, and then the name of the file. So this takes the .java file, converts it to a .class file, and now we can run the .class file. Let's see if it works like this. No, because it should not have the extension of the file. So the parameter is, the command line is Java, and then the name of a class that contains the application entry point main function. And since I don't specify any class path and the environment variable class path is not defined, then the current directory will be considered the class path, so the only directory where it will search for .class files. And the current directory is, you find it out by executing the Unix command line pwd. And can also be seen, in my case, in the bash prompt. Okay, you can find a slightly modified version of the Hello World app here. The program has an error. Fix the error so that the program successfully compiles and runs. What was the error? I know. Let's see. Copy link, wget, Ctrl-Shift-V, F4. So this is a doc string, a doc comment. This is called a file header. This is a line comment. This is the doc comment for the class. This is public static void main, and then the correct signature, system out print line, and then evenkate, which is not an ID, it's a developer text editor, has figured out the issue because it shows the comment in the wrong color. So instead of being gray, it's red, and red is the color for strings. So this string is never terminated. So let's terminate it. We can terminate it anywhere we want. For instance, here. Okay, so now all of these characters are part of the string that's going to be displayed. So H, E, L, L, space, W, blah, blah. Even close parentheses, semicolon, space, slash, space, display the string, dot. So all of these characters are part of a larger string that's going to be displayed to the standard output, which is what it does. Okay, but the correct way to fix this issue is to end the comment after the question mark, and the string after the exclamation point. Java C and then Java. Okay. Bytecode C. Class path, class not found. Public static void main args or public static void string array like this. Any number of strings. Interesting. The convention is public static. Okay, only one parameter named usually args, an array of strings. We did this, and we're closing the string that never closes in here. Okay. So this is questions and exercises getting started. Where are you? So we're at here at questions and exercises getting started. Next, common problems and their solutions. Java C is not recognized as an internal or external program, operable or program or batch file. This is because Java C is not in your path environment variable. Of course, so if you go which Java C, it will not find anything, so you need to amend your path environment variable. Java C command not found. Okay, you edit your path environment variable on Linux, Unix, macOS, and Windows. It's named the same, uppercase PATH. Okay, if there's a compilation error, it says that it's an error, what error, where the name of the file and the number of line, and it shows kind of where. So this is part of the actual file, what exists in the source code file testing.java at line 8. There's just this this increment of count, and then it says that there's no semicolon after the second plus. When there are compilation errors, no .class file is generated. If you're trying to use a variable, so in this case, count plus plus is the same thing as count equals count plus 1, but then it cannot evaluate count plus 1 because it doesn't know the initial value of count. So it gives the error count might not have been initialized. Fix the error and try again. If Java cannot find the bytecode file hello world app.class, in your current directory, you could change to the directory where the .class files you have created are. You can set the class path environment variable. You can use the -cp command line parameter to the executable named Java. So don't, when you call Java, don't put the extension name as we tried, the .class, because the Java manual says Java space the name of the class, not the name of the .class file. Exactly. There must be a main method. There's a class path environment variable. We don't use Java on the web browser. Okay, and that's it for the trail getting started. You have reached the end of the getting started trail. Learning the Java language, a gentle introduction to object-oriented concepts and how the Java language implements them, essential Java classes, strings, exception, threads, and other Java features that are used in all kinds of Java programs. So learning the Java language, which is this trail. Okay, and then essential Java classes, which is the next trail until development. A deployment, and deployment is applets, which is a web thing nobody does. Java Web Start nobody does. JNLP, Internet, Web Start, and again Web Start. Okay. Self-contained applications. That's interesting. Then there's jar files. This is interesting. And then creating a GUI with Swing, another trail. Collections of objects. Date, time, internationalization, 2D graphics with Java 2D, sound, MIDI, okay, Java beans, databases. I don't use such a thing. I don't know what this thing is. Simple API for XML. DTD. XSLT XPath. I don't do RMI. I don't do security features. Extensions. I don't know what that thing is. Reflection, really important. Networking URL. Sockets. Datagrams. Cookies. Generics. Java directory, no thank you. LDAP. Sockets direct protocol. I've never heard of such a thing. Okay, so what's interesting in here is generics. reading and writing to a socket, reflection, extremely short part of daytime. You need to get a current daytime. You need to get the time as precisely as possible with nanosecond precision if possible. You need to do time zones, and then you need to do time durations, so time intervals. Collection is important. Swing important. Jars important. And then these two important parts, trails, essential Java classes, and the learning the Java language. Okay, so let's go next. Learning the Java language. Object-oriented concepts. Objects, messages, classes, and inheritance. Language basics. Okay. Let's do these parts. If you've never used an object-oriented programming, you'll need to learn a few basic concepts. Object classes, inheritance, interfaces, and packages. What is an object? So an object is a package that contains states or variables and methods, functions, behavior. Okay, but this bundle you can have, for instance, from the same class created 10 bundles, so 10 objects, 10 class instances. Let's say you have the class car, and then you have the object my black personal car, and another object for, for an ambulance. Okay, so objects are instances. You need to use the keyword new in order to get to an object, whereas you get to a class by using the keyword class. So class is a type definition, whereas object is an instance. Inheritance, you can have parts of the state of one class being also available in another class, or signatures of a method defined in an interface be implemented by a class. Powerful natural mechanism for organizing and structuring your software. Interface is a contract between a class and the outside world. I'm not sure if classes can have interfaces, so interfaces are for objects. We'll see if you can have static member methods in an interface. I'm not sure you can. Okay, and the package is the first level of organization. So if the first level of organization is a application or a jar file, the next level of organization inside of your application are going to be packages. So they're going to contain many classes. Okay. So the red dog is an object, the black small dog is another object. So they're instances, they exist, they're different, but they're both dogs, and dog is a type. So dog is a class. Bicycle, change gears method, brake method, change cadence method. Fifth gear object, fifth gear data member. Attributing state, current speed, current pedal cadence, current gear. So these are, in fact, the current gear is an integer, whereas current pedal cadence is, a float, might have decimals. How many rotations per minute does the pedal do? And there is a method for changing gears that changes the value of the integer gear. You can do information hiding by making the variables that are contained inside of an object, so the member variables, be private, not accessible from the outside. But then you can create functions, public methods of the object that can read or write the member variables that are hidden by being made private. You pass around objects, so instances, by reference. I don't know what this thing is. What is a class? A class is a type definition. You'll often find many individual objects all of the same time. So 99% of the source code that I write, there's at most one instance of a class. But yeah, the theory sounds really nice, where you create a bicycle type and then you instantiate it 10 times to represent the number of bicycles you actually own in your basement. There may be thousands of other bicycles in existence. So this would be rows in an SQL database, in an SQL table. There might be thousands of rows in the bicycle table in an SQL database. And a class is the blueprint. So in this case, the class would be the table bicycle and its structure. So we know that it has a column called cadence with a default value of 0 and of type integer 32-bit, a column speed, default value 0, and integer 32-bit, gear default value 1, integer 32-bit, and then all of these columns are in fact visible just in our package because you give it package visibility. By not making it public, you're probably making it package visible. And then in here you're exposing some public ways to, well, not even these methods are public. Okay, and then there's methods that these are called the state. The member variables are called state, and these are functions that can read or write the state, because these functions are of the objects, not of the classes. So this method is not the method of the table bicycle, it's a method of the row bicycle. And how this is done is that there's a hidden argument on the first position that's called this, and it has the type reference to bicycle. So the entire row comes as parameter, as first parameter in here, before the int new value, which is the second parameter. Okay, so we have a parameter that contains the entire row, so the entire state, so cadence 0, speed 0, gear 1. And only then the second parameter is an integer that is the value that should be written to the cadence cell of the current row. So it takes the current row, it says this dot cadence, which is 0, and then it assigns to that the value, new value. So let's say this is 7, because 7 is being attributed to this dot cadence to this spot. So it affects the current row, the column cadence, which is in databases would be a cell or in a spreadsheet. Change gear is the setter for the gear state. Then there's speed up, which is a method that increments speed by a certain amount. So this is amount, and you go current speed plus amount, and this sum is attributed to this thing, to this storage field. And then apply brakes, which decrements the speed. You decrement the speed, so you take the current speed, you decrease it with the decrement, and then the result, apply it to the current cell speed. And then there's a print states that goes string cadence plus the current value of cadence, which is an integer, gets converted into string, so it's, I know, the string 7, then string concatenation space speed, and then writes the current value that's stored in the field speed, and then space gear colon, and then the current gear, which is, I know, 1. All of this string concatenation, the result of string concatenation, is then printed to standard output. So the fields cadence, speed, and gear represents the object state. The methods change cadence, change gear, speed up define the interaction of the individual object with the outside world. There's no main method. Bicycle is not an application. Bicycle is useless until you say you use the new word, the new keyword. So until you go new space bicycle, you can't really do anything with bicycle. It has no static methods. Okay, and then there's a bicycle demo class that actually has a application entry point, so public static void main array of strings args that creates two different objects. So new bicycle once, new bicycle twice, and then it calls some methods for the first bicycle, so for this object, and it calls some methods for the second object, the second bike. And this is the result that we get. Let's actually do this example. So we open IntelliJ IDEA. Let's close the current project. We go new project, and this is bike demo. No sample code. Create. Okay, and inside of the src directory, there's no namespace, no packages. So we'll need to have two classes, one called bicycle and one called bicycle demo. We'll create one .java file per class. We'll start with the one that has the main entry point. Ctrl C, new Java class, Ctrl V, and then we put this thing inside. Ctrl S, trailing new line, Ctrl S, and then we need the bicycle class. src new Java class, Ctrl V, and then we put this content. Ctrl S, trailing new line. Okay. And let's put some breakpoints everywhere in all of the methods. We can't really put breakpoints on lines that are not executable. And we'll put a breakpoint at the very start of on the first command line, on the first source code line that actually gets executed, which is 6. Okay. And if we go to the bicycle class, there's no green triangles here. We cannot start this class. Whereas if we go to the bicycle demo class, it shows one triangle, a second triangle, and a third triangle. Okay. And in the main toolbar, the buttons to start and debug are disabled for bicycle, which doesn't have a main method. Whereas in here, if there is a main method, the buttons run and debug are enabled. So we can go, for instance, like this, or like this, or like this, or like this, or there's the view for debugging somewhere. Okay. So what does it do? We have a type that's called bicycle. So type, if we have a type and the type of the type is class, if it uses the keyword class, then this is a class. You define a class once, for your entire application, whereas you might have a million of instantiations of that class. When you go new and then the name of the type, it allocates a in RAM space in order to store the member data which is defined in the blueprint in the type, so these 3 ints, and then a reference to that zone of RAM is defined, and you get that reference back. So new returns a reference, and then that reference gets stored in this local variable, which is called bike1. So bike1 will be a reference to an actual object of type bicycle, and bike2 will be a local variable that contains a reference to another object of type bicycle. So 2 objects and just 1 type, just 1 class. Okay, there's a difference between classes and objects. Classes look like this, and objects look like this. Totally different. An object is 1 line of code, and the class is usually more than 3 lines of code. Totally different syntax. Okay. So let's go step over, and it shows that the cadence is still 0. Okay. This thing get initialized where the constructor of the bicycle would be, and the bicycle is a class. We didn't define any constructor for the class, so the class has a implicit default constructor, and we can actually see what that is. Let's actually look at it. So output production bike demo bicycle, this thing. I go double click on it. And we can see that there's a constructor that was created by default by the Java compiler, and it's empty. Doesn't have any arguments, doesn't have any body. Okay. Next, we have 2 local variables which are objects of type bicycle, which is a class. Okay, if we hover over bicycle, where are you? What's it going to say? So control click on bicycle takes us to the class definition, and control click on bike1, which is the object identifier. It will take us to the place where we define the type of the object. Okay, so bike1 is similar to an array or a hash map or something. We can evaluate it at debug time when we're stopped. We can see all of its fields and their values. You cannot inspect the value of a method. Methods don't have values. You can inspect the value of a variable that's member of an object. There are also variables that are member of the class, not of the object. Okay, and now we call the setter, whatever the state modifier method named change cadence. So this will increment the cadence from 0 to, or what it was before, from 0 to 50. It will go 0 plus 50 equals 50 and assign the value 50 to cadence. Let's go inside and see what it does. So step into. Oh, it just assigns, it doesn't increment the cadence, it just assigns the cadence. Step over. and new value is 50, and cadence now is 50. So we can see it in here that the cadence is now 50. Okay. Let's inspect bike 1 again. Cadence 50, speed is the default value, which is 0, gear the default value, which is 1. Speed up 10, so this actually increments the speed from 0 to 0 plus 10, which is 10. Step into. Okay, so this is going to go 0 plus 10 and equals 10 as integers. And now the member variable speed is 10. Here, here, and here. Change gear just assigns the gear from 1 to 2. Step into. Okay, so new value is 2. The current value is 1. So it will assign 2 to gear. Step over. Step over. And now gear is identical to the new value, which is 2. And we can also see it in here. In here. Cannot inspect this thing in here because we're not in this frame. So we're not in this method. This is the first thing that was pushed in the call stack, and this is the second thing that's pushed in the call stack. So this is the caller main, the main method is the caller, and the callee is the change gear method. So we'll go F8 step over, we return back to the main function, and now the call stack only has one function. The executable started here, and now we're in this exact same method. Okay, let's inspect bike 1 again. So it's cadence 50, speed 10, gear 2. Okay, and now we print states, which does that big concatenation. Okay, so cadence 50, speed 10, gear 2. It created a long string concatenated string, and it has written the string to the standard output. Step over. Okay, step into, step over, step over, step over, step into, step over, step over, step over, step into, step over, step into, step over, step into, step over. So it was 10, and then it incremented it by 10. 10 plus 10 is 20, and now it has assigned the value 20 to the cell speed in the current row in the table bicycle, the SQL database, as it were. Just assigns, then print states, computes the long string, which then it writes to the standard output. Next, inheritance. So there might be a bicycle class, a mountain bike class, or not an object, not a mountain bike object, not a road bike object, but a different class. So this is a Java type, this is another Java type, another Java type, another Java type. And you say mountain bike extends bicycle. So mountain bike extends bicycle automatically receives all of the methods and data members that are defined inside of bicycle. this creates a subclass when you say use the keyword extends. So class mountain bike, this thing, extends bicycle, this thing. This is the inheritance. Okay. Different kind of objects often have a certain amount in common with each other. Mountain bikes, road bikes, tandem bikes all share the characteristics of a bicycle: current speed, current pedal, cadence, current gear. They also have different features. Tandem bicycles have 2 seats and 2 sets of handlebars. Road bikes have drop handlebars. Mountain bikes have an additional chain ring, giving them a lower gear ratio. So mountain bike, just using this short syntax, mountain bike has received all of the same fields and methods as bicycle. But you could have new things added in here, like new methods which are specific just for mountain bike, new fields that are specific just for mountain bike. Okay. What is an interface? An interface is a keyword. There's keyword interface, so it defines a type. In this case, the identifier of the type, the name of the type is bicycle, and the type of the type is interface. So until now we had class and then the name of the type, and in here we have interface and the name of the type. Objects define their interaction with the outside world through the methods that they expose. Methods form the object's interface with the outside world. The buttons on the front of your television set are interface between you and the electrical insides in the plastic casing. Press the power button to turn the television on or off. An interface is a group of related methods with empty bodies. So change cadence, no body. Change gear, no body. Speed up, no body. And apply brakes, no body. But instead there's semicolons. Okay. So you might have bicycle being not a class, but an interface. All of the methods do not have bodies. All of the methods do have a signature. And there's no instance member variables. And then you could create the Acme Bicycle class. You say it implements bicycle, automatically will get these signatures, but you cannot leave a class with methods that don't have bodies, so you'll need to start putting bodies to the class, to the methods. So change cadence, you put a body to it. Change gear, you add a body. Speed up, body. Apply brakes, body. And then you might want to add additional methods. And you might want to add state, so member variables. Okay, if you do not put these lines, the compiler will complain or say, Acme Bicycle is a class that implements the interface bicycle. The interface bicycle has defined all of these methods, so Acme Bicycle should define all of these methods, but then you should not leave the methods empty-bodied. Compilation will fail if the methods are missing from the class, if the methods do not have bodies. interfaces form a contract between the class and the outside world. One class might implement 10 interfaces, like what we have seen with system out println. So println is a member of print stream, which print stream implements appendable, which is an interface, implements closable, which is an interface, and extends a class. And also out is a print stream, and the print stream again implements these two output stream implements the same closable and flushable. So these are interfaces with just one method. Flushable has the method flush. The interface flushable, the interface closable has just the method close. And appendable has the methods append, char sequence start end, and append char. Closable just as close. Okay. So all of the implemented interface methods will need to have public visibility. Okay, and the Java-C compiler helps us along the way by giving us compilation errors when we do not put the correct visibility, or when we do not put bodies to all of the methods that have definitions inside of the interface, etc. A package is a namespace that organizes a set of related classes and interfaces. So packages are similar to a directory on your computer. You might have HTML pages in one directory, images in another directory, scripts in another directory. Sometimes you have hundreds or thousands of individual classes in Java. Yeah, easily you have hundreds of classes. Makes sense to keep things organized by placing related classes and interfaces into packages. Okay, so let's see some of these packages. There's java.lang for system. There's print stream in java.io for input output. So the Java API application programming interface, the standard library that comes with the Java SDK and runtime environment, contains many classes, and they're grouped in packages. So there's, I don't know, maybe 100 packages in the Java standard library. Java applet for deprecated web browser things, Java auth for a GUI that's simpler than Swing, with its sub packages, so color, data transfer, DND event, font, geom, input method, SPI, image renderable, print. Then there's java.beans.bean context, input output, the programming language Java, annotations, instrumenting the virtual machine, dynamic language support, java.lang.invoke, management interface, java.lang.management, reference object classes, reflection, mathematics, networking, new input output channels, service provider classes, charset, file attribute. So some of these sound like they're a class, like java.nio.file, but no, it's a package. It contains a ton of interfaces and classes. So there's 6 enums, (15 interfaces, 8 classes, many exceptions. Okay, so that's what packages are for grouping related classes, interfaces, enums, exception types. Next. Real-world objects contain member data and member methods. A software object state is stored in member data. Member variables, a behavior is exposed through methods. Hiding internal data and accessing it only through publicly exposed methods is known as, encapsulation. A blueprint for a software object is called a class. Common behavior can be defined in a superclass, base class, inherited into a derived class using the extends keyword. A collection of methods with no implementation is called an interface. A namespace that organizes classes and interfaces by functionality is called a package. The term API stands for the Java Platform's Standard Library. Application Programming Interface. Create new classes for each real-world object that you observed at the beginning of this trail. So there's a bicycle class. For each new class that you've created above, create an interface that defines its behavior, then require your class to implement it. Omit 1 or 2 methods and try compiling. What does the error look like? Real-world objects contain state and behavior. Object's state is stored in fields. Object's behavior is exposed through methods, encapsulation, superclass, subclass, extends keyword, interface, package, application programming interface. Okay. Where are we? We're at the language basics. Variables, operators, expressions, control flow. Let's go next. An object stores its state in fields. How should we name a field? What other types can you use instead of int? Is it mandatory to assign when you declare, or can you just go int space cadence semicolon? If you don't do assignment on the same line where you declare a variable, is there a default value? Field and variable are both used. Instance variables, non-static fields. Objects store their individual states in non-static fields. Fields declared without the static keyword. Non-static fields are also known as instance variables because their values are unique to each instance of a class, to each object. Okay, so the current speed of one bicycle is independent from the current speed of another instance of the bicycle class, so from another object. Then there's also static fields, which are class variables. Class variable is any field declared with a static modifier. There must be exactly one copy of this variable in existence. Doesn't matter how many objects of that type exist. So no matter how many times you went new and then the class name. For instance, the field containing the number of gears for a type of bicycle. So if you create a new class called 6-gear bicycle, you might have a static int num gears equals 6, a static field. If you use final, then that value will never change. So if you go static final int num gears equals 6, then you can never change this value. Okay, local variables exist inside of a method. If it's between the open and closing braces of the body of a method, then it's a local variable. Are only visible to the methods in which they are declared, so only visible inside of the body of the method. Parameters. The main method has the parameter called args. Types, fields, methods, nested types are called members. Okay. There are rules and conventions for the identifier, so for the name of a field or variable or parameter or method name. So variables, everything in Java is case sensitive. A variable's name can be any legal identifier. an unlimited length sequence of Unicode letters and digits beginning with the letter, the $, or the underscore. Additionally, the $, character by convention is never used at all. Auto-generated names will contain the $. Your variable names should always avoid using it. It is discouraged to have the identifier starting with underscore. White space is not allowed. Okay, so it says Unicode letters and digits, so I've never used such a thing. So I always used just the English alphabet, so small case A to Z and uppercase A to Z, and then 0 to 9, and might have underscore somewhere in the identifier, but not at the start of the identifier, because in Java you should not do this. Digits, letters, $, underscores. I never do $, in identifiers. Don't do cryptic abbreviations, do whole words. It will make your code self-documenting, so fields named cadence, speed, gear are way better than S, C, and G, right? You should not use a keyword or a reserved word. Keywords. Reserved words. True, false, null are literals. Okay. So const and goto are reserved, and true, false, null are literals. And there's the keywords that we saw already, which is for, new, package, boolean, double, implements, public, return, extends, int, char, final, interface, static, void, class, long, float, super, and the rest are abstract, continue, switch, assert, default, synchronized, do if, private, this, break, protected, throw, byte, else, import, throws, case, enum, instance of, transient, catch, short, try, char, finally, long, strict FP, volatile, float, native, while. Okay. If you have just one word, spell the word in all lowercase for fields. So for instance fields, for class variables, local variables, and parameters. So what this says is that you should use what I call Java casing. So words next to each other without any space between. The first word starts with a lowercase, And the next word starts with a uppercase and then all of the other characters are lowercase. So current gear is all of the letters are lowercase with the exception of G. Gear ratio, everything lowercase, are uppercase. So if there's 3 words in the identifier, then the second and the third will start with a uppercase letter and then lowercase the rest of it. And then it uses snake casing for const values, static final int numGears equals 6. So uppercase all of the letters, and then you cannot really separate the words as you do in here. You separate the words by the alternance lowercase, one single uppercase and then lowercase again. In here you must separate the words with underscore. Okay, next, primitive data types. The Java programming language is statically typed, so you need to specify all of the variables, fields, arguments. When you define them, you need to specify their type and their name. So you cannot just go variable a is assigned a 1, you must say int a equals 1. And then you cannot change later on the type of the thing. So if you say int a equals 1, then you cannot go a equals the string hello. So statical strong typing. Okay, so at compile time, the compiler will know that you have, in that example, a data memory field named gear. It will know its name. It will know its type, so it's int32, probably. And then it knows that it should be assigned the value 1 at initialization time, so when the field is defined. Okay, so the Java programming language has 7 primitive types plus int, so 8 in total. Is named by a reserved word. Is predefined inside of the Java programming language. They do not share state with other primitive values. The 8 primitive data types supported by the Java programming language are integers. There's byte, 8-bit, short, 16-bit. So these are signed. So byte is signed int 8-bit in a 2's complement integer. Okay. Short is a 16-bit signed 2's complement integer. Int is a 32-bit one. Long is a 64-bit one. So there's 8 primitive types, out of which 4 are signed integers. 8-bit, 16-bit, 32-bit, 64-bit. So 8 at the power of 1, 8 at the power of 2, 8 at the power of 3, and 8 at the power of 4. No. No. So 1 byte, 2 bytes, 4 bytes, and 8 bytes. Okay, so their values go from 2 at the number of bytes, so 2 in the case of int at the power 32 minus 1, to 2 at the power of 31 with minus, to 2 at the power 31 minus 1. I don't know how unsigned ints are represented. They say that Java 8 has unsigned ints, unsigned long. Compare unsigned, divide unsigned, etc. There's a class that's a twin of the primitive type. So int, which is 32-bit, has a class twin which is called integer. So integer is defined in java.lang, whereas int is defined inside of the engine of the Java programming language. So not in the standard library, whereas integer with an uppercase I is defined in the standard library in the API. Okay. You use byte often for buffers, which is arrays of bytes. Then for other primitive types remain. 2 are for decimal numbers, so for numbers that have a integer part and a decimal part. Float is 32-bit IEEE 754 floating point. That thing with Mantissa. Okay, 64-bit floating point is the type double, which is a primitive data type. Not all numbers can be represented in the type double. Don't ever store precise values such as currency. I don't know what I would use float between float and double. I kind of never needed neither float, neither double for tens of years in my day job programming. So whenever you need float or double, do study these types, do see their limitations, what can you represent on float or double, and what can you not represent there. There's the type java.math.bigdecimal for precise values such as currency. If you want to save memory in large arrays of floating point numbers, consider not using double but using float. Everywhere else, prefer double to float. For decimal values, this data type is generally the default value. Okay. And 2 more primitive types remain. Boolean, which has only 2 possible values, true and false. This data type represents 1 bit. We do not know the size of a variable that has a type boolean. Okay, interesting. So char is a data type that is a single 16-bit Unicode character. It has a minimum value of \0 and a maximum value of \u FFFF. So FF would be 1 byte, and 2 FFs, that's 2 bytes, which is 16-bit Unicode character. So there's special support for character strings in the string type. That's part of the API, is not a primitive type, primitive data type. So literals, which are character strings enclosed in double quotes, will create a string automatically, string object, like this. String objects are immutable. You cannot change the value of a string object. The string class is not a primitive data type, but the language gives it support, so it behaves like a primitive data type. Okay. It's not always necessary to assign a value when a field is declared, so field being a static or non-static data member of a class or of a object. Fields that are declared but not initialized will be set to a reasonable default by the compiler. The default will be 0 or null depending on the data type. Relying on such default values is considered bad programming style. Okay, so byte being all of the four primitive data types that are ints default to 0, float and double default to 0, chars defaults to 0, 0, 2 bytes, string and all objects default to null, so string is nullable, and then boolean defaults to false. The compiler never assigns a default value to an initialized local variable. Accessing an initialized local variable will result in a compile time error. Okay. You don't need to use the new keyword in order to assign to initialize variables of primitive types or string. They are not objects created from a class. A literal is the source code representation of a fixed value. Okay, so this is a literal, this is a literal, this is a literal, this is a literal, this is a literal. So this is a boolean literal, this is a 16-bit char literal, a 8-bit literal, a 16-bit literal, 32-bit literal. So int 32, int 16, int 8. Okay, if you want to specify long, then it should end with L, lowercase or uppercase. Otherwise, it's going to be int 32. So if you put 10,000 and then an uppercase L, that thing will be a literal of type long. So int 64. Otherwise, it will be a int32. Okay, let's always use uppercase L instead of lowercase l. You can create all of the 4 primitive types variables from int32 literals. If you have a long literal that is greater than what can be represented on int, you must use uppercase L. Okay, there's base 10, base 16, base 2. Base 10 goes 0 through 9. Base 16 goes 0 through 9, 8 through F. And base 2 only has 2 digits, 0 and 1. Okay. And binary is 0B and then the individual ones and zeros. Hexadecimal is 0x and then 09AF as many times as needed. Base 10 is without any prefix or suffix. Okay, floating point literals. Are double by default, and if you want narrower, so if you want float, then you must put an F at the end. You can use scientific notation, which is with E, so you go E2. So that's 1.234 E2, which means times 10 at the power 2 of 2, so that's times 100. So that's 1, 2, 3, period 4. Okay. There's double literal, float literal, E, uppercase and lowercase. Literals of type char and string may contain Unicode characters. You can put Unicode characters directly in the source code file, or you can use Unicode escapes such as \u and then something in what's this, decimal, hexadecimal. So there's 2 bytes. The first one is the base 16, 0 and 1 digits, and then the other byte is base 16, 0 and 8 digits. Si, senor. So this is the English alphabet uppercase S, where this is I with an accent. These are English alphabet uppercase S and lowercase e. And then this part with 2 bytes is new. And then you go OR. Always use single quotes for char literals and double quotes for string literals. I've never done field names with Unicode characters. Inside of a char or a string literal, you could have \b, which is backspace, \t, which is tab. So these things are from the ASCII table. Okay. So \b is the character with base 10 8. So this thing b as backspace, and then \t is the tab, which is horizontal tab, which is the base 10 9, and then \n is this decimal 10, new line feed, new line lf, then \f. I have never used \f. Form feed, what is that? I don't even know where it's hidden. In here, form feed. This thing, ff12 form feed. I have never used this thing, hopefully never will. \r is exclusively for Windows new line terminals. So this is 13, cr, carriage return. And then if you want to escape the single or double quote, you go / single double quote or / double quote. And then because / is used for escaping, you need to escape itself if you don't want to use. If you want a literal / and a literal t, you go / t. Otherwise, a / and a t makes just a tab. Okay, there's a special null literal that can be used as a value for any reference type. Null may be assigned to any variable except variables of primitive types. So there's 4 types that do not accept null, 8 types that do not accept null, which are the primitive ones, but even the string and the other types do accept null. String.class is called a string literal. Refers to the object of type class that represents the type itself. Okay, I don't know what that thing is. And you can use underscores in numeric literals. We won't go there. I've never done it. Okay, and now we get at arrays. An array is a container object that holds a fixed number of values of a single type. So you might have in all of these cells just int 32. And you know from the start that its size is 9 or 10, 0 through 9. The length of the array is established when the array is created, so it's not a dynamic array. After creation, the length is fixed. Inside of the main method, we had that for int integers for int32 array. First element has index 1, the last element has index array length, which is 10, in this case -1, so 10 minus 1 is 9. Okay, so this is a pair of things. There's an index, a value, an index, a value, or an index, a cell, an index, a cell. Each cells should have the same type, and when you specify the type of the array, you go the type of the cell, and then square parentheses. This just declares an array of integers. It doesn't initialize it or allocate it. So you go new int of 10. So this allocates in RAM, in random access memory, 10 cells, each of type int32. And then you can write in individual cells. So in the cell 0, which is the first one, you can write 100, then 300, 400, 500, etc. You can read at index 4, so that's the 5th element, using the same syntax. So you use the same syntax for reading and for writing. When you want to write to a cell, you go array name square parentheses 4 and equals something. When you want to read from the cell, you go array name square parentheses 4. So this would be a right hand side where you read from the cell, and a left hand side when you write to the cell. Okay, so instead of having this many system out print lines that are essentially identical, the only difference is that this thing, which is the iterator, the loop variable, this keeps increasing by 1. You might have just this part as the body of a for each, and this would be the variable I that you used for looping, the lowercase I variable. So it says in here, in real world programming, you should probably use one of the supported looping constructs, so repetitive structures. The example clearly illustrates the array syntax. Okay, array demo. Let's see this thing in action. Oh. So it was not able to break, the debugger was not able to break on this line where I just declare a local variable. But it could break on the line where I assign it a value. Okay, so array is of unknown size. Cannot find local variable an array. Okay, now it allocates memory for 10 cells of type int32. It returns a reference to that, and the reference we assign it to an array. Okay, and I can see default value 0000. I'm not sure why. Maybe it always initializes to 0, or because we're maybe compiling in debug mode. Okay, so at position 0, which is the first position, there's a 0 now, but a 100 will be written. F8. Okay, on position 2, which is index 1, there's a 0 and a 200 will be written. On position 3, which is index 2, there's a 0, 300 will be written, etc. 400. The last one will be 1000. And now, in the reverse of, in here we wrote to all of the cells, in here we read from all of the cells. Okay, and let's look at the console output. So you go F8, it wrote element at index 0 is 100, element at index 1 is 200, so 2 is the third item. The third item is 300. Okay. 6 is the seventh item, and that's 1, 2, 3, 4, 5, 6, 7, 700. Okay. Declaring a variable to refer to an array. So it declares an array. And here it just declares it. Arrays type, arrays name, type, and then a pair of square brackets. The size of the array is not part of the type. An array's name can be anything. Okay, we should follow the naming convention. Okay, so just specifying the type and then the identifier doesn't actually allocate, doesn't actually use the new keyword. It simply tells the compiler that this variable will hold an array of the specified type and nothing else. It will not contain a string. It will contain an array of int. So array of byte, array of short, array of long, array of float, array of double, boolean, char, and string. This form is discouraged. To go type, identifier, and then a pair of square brackets. Okay. In order to assign or initialize an operator, an array, local variable, you need the new operator. Okay. So it goes an array equals new int of 10. In here it actually allocates memory, and we receive a reference to that to that newly allocated array of 10 int32s. Let's see what if we don't have this line. We could either delete this line not to have it or comment it out. Okay, Control S, and then let's compile it. It says variable, an array might not have been initialized. Variable, an array might not have been initialized. And it says line 10 and cell 9, which is line 10 and column 9. This thing. So in this exact spot. Okay. Which is a good thing, because otherwise in here I don't know what memory will be written, because this thing was not allocated. What would this thing do? It doesn't have it doesn't have storage for the first cell in the array. And also the size of the array is not known, which is illegal, because size of arrays cannot change in time. Okay. Then we make assignments in here. And then we make a reading. We read from the array in here. We use its numerical index. So the type, the identifier of the array. And within a pair of square parentheses, we have the numerical index. Okay, we can create the array all at once without any assignments or new or declaration, like this. So the compiler will know the name of the local variable, will know its type, will know its size, and will know to allocate it with new of int32 10 cells. Okay. And it's the same output as before. You can declare an array of arrays, multi-dimensional array. So many pairs of square brackets. A multi-dimensional array is an array whose components are themselves arrays. Rows are allowed to vary in length. Multi-dimensional array. Rows are allowed to vary in length. Okay, let me see what this thing does. Okay, so it declares a type which has an x coordinate and a y coordinate. On the x coordinate there's two slots, 1 and 2, and on the slot 1 you have an array with Mr., Mrs., Miss, and on the second you have an array with just Smith and Jones. Makes total sense. or doesn't it? So we know that this contains two arrays, but we don't know the second dimension. Okay, interesting. Mr. Smith and Miss Jones. Mr. Smith So Mr. Smith is at index 0 and 0, and Smith is at index 1 and 0, correct? And Mrs. Jones, index 0 and 2, and 1 and 1. Correct. There's a built-in length property to determine the size of any array. Property. Since when are there properties in Java? Says public final int length. So it's not a property, it's a member variable, a public one, and an unchangeable one. You cannot navigate to it. And it says something about the type. Where are you? Minus array underscore array underscore. Okay. Copying arrays. The system class has an array copy method that you can use to efficiently copy data from one array onto the other. Source and destination. The source position, destination position, and how many? From copy to 7 elements starting at position, at the third position, so index 2. Okay, let's try this one. There's spell checking. Replace with abrogator. Okay. It doesn't line wrap, which I don't like. I do not want to see left, right scroll bars. So let's fix that. Where are the settings? Wrap. Soft wrap. Okay, so it shows this glyph when the line 5 is displayed on two lines. So it you can see the line number for this is 5, for this is still 5. Okay. There's enough hints for me to know that the line was wrapped like this. So line 5 now is here, 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 and here. And this is where line 5 ends. Okay. So what does this thing do? It creates a string array of a huge length, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then it copies from the source array to another array that can hold just 7 strings, starting at position 2, which is cappuccino, 7 elements. So cappuccino, 2, 3, 4, 5, 6, 7 until Fredo. These things. Puts them in this storage in RAM, in random access memory, and then with a for each we print on a single line all of their values. So let's run it first. Where are you? So says cappuccino, corretto, cortado, doppio, espresso, frappuccino, Fredo. Okay. And with the debugger, where are you? So copy from is an array. This is the icon for arrays. It says 13 strings, starts with avocado, affogato, poco, affogato, and ends with ristretto on index 12. The first index is 0. So at index 2 is cappuccino. From index 2, 7, it's until Fredo. Okay, next. System array copy. And now we can inspect the other local variable, which is called copy2 of type array, length 7. The cell is of type string. And then with the for each, it prints everything on a single line. So it concatenates coffee and then a space. And we can look at what's written in the console. So it keeps writing a string plus a space. Okay, and in here it puts an extra space and it forgets to print a new line. Okay. Array manipulations. Array copy demo. Array copy. Interesting that this C is lowercase, should have been uppercase. Identity hash code is uppercase hash uppercase H uppercase C, whereas array copy is lowercase c, which is a strange exception to the rule. So T is uppercase T, current time millis, so time is a word starts with uppercase T, millis is a word starts with uppercase M. Security manager, uppercase S, uppercase M. Okay. Array manipulators, copy of range. Okay, we'll skip over this. There's filling an array, the fill method, comparing two arrays if they are equal or not equals method, binary search, Java util arrays, parallel sort, stream, copy to, map. Okay, next. Summary of variables. So we have fields of two types, we have local variables and arguments. Okay, what else? Long string, Java long string behaves like a primitive and has some support from the programming language and the compiler, but it's defined in the API and is nullable. Fields and static fields get initialized by default, local variables not. There's literals. Next. Exercise is a term. Instance variable is another name for state, for member variables, for fields, for so they're members of the object, not of the class. Class variables, static fields, static member variables. It is declared inside the body of the method, so inside the curly brackets of the body of a method. A variable declared within the opening and closing parentheses of a method signature. So this is an argument or a parameter. 8 primitive data types, so there's 4 ints, int 8, int 16, int 32, int 64. So they are named byte, short, int, and long. There's 2 floats, there's float and double. One is 32-bit, the other is 64-bit. There's char, which is 2 byte, and the base is for string. And the last one is boolean, which has 2 bits, but we do not know its size. Okay, character strings are represented by the class uppercase S string. An array is a container object that holds a fixed number of values of a single type array. Create some illegal field names. Let's create an illegal field name. How do we do that? Like this. And then we compile it. So it says that after int, it expects an identifier, not a multiplication. Okay, check the answers. Instance variable, another name for non-static fields. Class variable, another name for static fields. Local variables declared inside a method. Variable is a parameter or argument. This I'm sure I knew them. Java long string array. Okay. And now operators. So might be single operand, two operand, or three operand. And then return a result. There's a table of operator precedence. If you do not like the default operator precedence, you can use as many round parentheses as you want. The closer to the top, the higher its precedence. So postfix, increment, decrement is the best precedence, and assignment is the worst precedence. Operators with higher precedence are evaluated before operators with lower precedence. Operators on the same line have equal precedence. All binary operators, except for assignment, are evaluated left to right. So A plus B is evaluated left to right, whereas A equals B is evaluated, you first find out the value of B and then you send that thing to A. Assignment operators are evaluated right to left. So these are assignment operators. There's many of them, not just equals. This is the one that is a ternary operator, so it has three operands. The only one, the ternary. Okay. There's logical or, logical and, bitwise inclusive or, bitwise exclusive or, bitwise and. So this is for bit operations. Okay, so the operations in base 2. Equal, not equal, instance of has the same precedence level as less than. Shift operators, add plus, multiplication. So this is multiplication, integer division, and modulo. Unary prefix. And this is really not needed. And this is 0 minus expression. This is negation. This thing is Boolean not. And this is I don't know what. And this I do not know what it does. Okay, so you should know what you do not know. You know that you do not know this one. You know that you do not know this one. This one. Not a problem. You'll study them if you encounter them. If not, that's it. Assignment, arithmetic, and unary operators. So there's simple assignment, arithmetic. So this modulo does integer division and returns the remainder, whereas this does integer division and returns the, I don't know, what's the name of that thing? Not the remainder. If both parameters, if both operands are integer. Okay, let's do this thing, arithmetic demo. Let's make this smaller and this smaller. Let's hide it for a while. Let's see what it does. Start with the debugger. So result is initialized with the value of a arithmetic operation. So 1 plus 2 is going to be so this is the operator, as it says. This is the assignment operator, has the lowest possible precedence. So you need to evaluate this, and it says that assignment operators are evaluated right to left. So first you evaluate this, then this. So what is 1 plus 2? There's 2 operands with 1 operator, plus binary operator. You don't need to look at the operator procedure precedence. So it's 1 plus 2 is 3. So the integer 3 in 32.3 is assigned to result. So result will be 3. Okay, it says result equals 3 in here. And then we print the result. You can see it in the console. And then 3 minus 1. So again, assignment, we evaluate right hand side. This is 3 minus 1. Minus is the operator, 2 operands. No need to look at the operator precedence table. 3 minus 1 is 2 assigned to. Okay. Original result is 2. Result is result times 2. So result is 2 times 2. So again, assignment. Evaluate right hand side. This is 2 times 2. This is 4. And then you assign to result 4. Okay. Original result is 4. And then you go result integer division 2. So result is 4. Integer division 2 will return 2. Okay, 2 plus 8, that will be 10. And then 10 modulo 7 will be 1, and with the remainder will be 3. So 3 will be assigned to result. Okay. Next. You can also combine the arithmetic operators with a simple assignment operator to create compound assignments. So there's plus equals. So x plus equals 1 is the same thing as x equals x plus 1. So it's kind of a sugar syntactics over this over this. The compiler will interpret both the same way. Just increments whatever value is in x by 1. And string concatenation is also with the plus operator. Let's put a breakpoint here. Let's debug this thing. Close this thing. So there's one string, a second string, both initialized with the value of a string literal, whereas the third string is initialized with the value of a string concatenation. So this is the assignment operator. First, it interprets right-hand side. This plus this is in fact this concatenated with this. So the result will be this is space a space concatenated space string dot. Okay. So we can inspect the 3 strings here. We can see the result here, and the ID shows us the values that the ID thinks we're interested in seeing. Okay, let it continue. Unary operators. Plus minus unary. So plus 7 doesn't do anything. Minus 7 is a negative value. Like this. Plus 1 is just 1. If you go minus result, this is the same thing as 0 minus result. Result minus minus, this decrements result by 1. Result plus plus increments result by 1 because of this sugar syntactics. There's pre-increment and post-increment. Logical not. Okay, let's see unary demo. Debug this thing. Reload. Okay. So plus 1 is the same as 1. Minus minus is the same as result equals result minus 1. Result is 1, but if you go 1 minus 1, that will be 0. So result will be 0. So this is called the incrementing result. It was 1. Now we incremented it by 1. It's 0. Then we increment it by 1. It becomes 1. Then we go 0 minus result. So 0 minus 1 is minus 1. And then Boolean success is false. So this is not a success, it's a failure. This will print false, and not success will print true. Okay, that's it. Increment operators could be applied before prefix increment and decrement and postfix increment decrement. So this is postfix decrement and this is prefix decrement increment. Result will be incremented by 1, but this returns something, and this returns something. What does it return? The prefix version evaluates, so it returns the incremented value. So if result is 0, plus plus result will return 1. Whereas if you go, if result is 0, result plus plus will return 0. Okay. I never had bugs because I used the wrong increment or post increment or postfix or prefix. because I don't use these things in I don't know, in comparisons or something. Okay, let's see the example. So it says pre-post demo. Reload. And we need a breakpoint and debug. So let's go to the console view. In the debug, Alt F5, Alt +5. So I will be declared as int32 and initialized to 3. Then it increments I, so it's 4 and returns 3. If it prints, it's 4. Plus I is going to be 5, prints 5. Whereas here it will print 6 and I will be 6. Whereas here it will print 6 and I will be 7. And now it just prints 7. Okay, next. Equality, relational and conditional operators. So this is equality, this is not equal, greater than, less than, the normal things. Booleans and or. Okay. This is the ternary. So if some condition which is true, then value 1 will be the result of computing this entire thing, and value 1 is 1, so this will be evaluated to 1, and to result will be assigned the value 1, which will then be printed. Result for me is a special semi-reserved name, so this is always used as the local variable that's returned by the current function, current method, only if the current method doesn't return void. Instance of. Okay. There's a parent and a child to classes. Parent doesn't have anything, and child inherits parent and implements my interface. And there's an empty my interface. Let's see this thing. So it creates two objects, a parent and a child. A parent is the simplest class ever. The child instead contains the parent because it extends it, and it implements interface, my interface. But because my interface does not define any member methods, then the body of the class is empty because no methods need to have a body. Okay, so parent, child, and my interface. So parent is a class, my interface is a interface. Child is special because it extends parent and implements my interface. Child extends parent. Child extends parent. Interesting. Okay. Let's go with a debugger. So is a parent instance of parent? Yes, it is. Is parent instance of child? No. Is parent instance of my interface? No. Okay, whereas child is everything. Okay, everything's true, correct. Null is not an instance of anything. We will not do bitwise and shift operators, so there's unary. This tilde is unary bitwise complement operator. No, thank you. Summary of operators, simple assignment, arithmetic, unary plus and binary operator. Increment, decrement, post increment, pre-increment. Comparison, equality, booleans, ternary, shorthand for if then else statement. Instance of, and we jumped right over the bit operators. Which operators does the code contain? So there's a plus, there's a greater than, and array index is not an operator. Just to. What are the values of I and n? So I is 10. We don't know the precedence between I++ and percent, so I'm going to guess plus plus has huge priority, so it's going to be 11. Then this times is the modulo operator 11, modulo 5 will be, the remainder will be 1 because it's 11 minus 10. What are the final values of I and n if instead of using the postfix increment you use the prefix? Okay, so they got me. So although this increments the I, what it does return is still 10, the original value. So this is going to be 10 modulo 5, the remainder will be 0, so n will be 0. Whereas if we go prefix version, so plus plus I will receive the value 11, but it's never being used. What is being used instead is the value of plus plus I, which is 11. And then modulo 5, that's 1. To invert the value of a boolean, you use the exclamation mark. Which operator is used to compare two values? This is assignment, this is equality. Explain the following code sample. This is a ternary. If this condition, then this value 1 is assigned to result. If this is false, then value 2 is assigned to result. Okay, let's do this one because this is relevant. Arithmetic demo. Already exists arithmetic demo. 1. Control S, and let's see what it does. So it says result equals 1 plus 2. And we should use compound assignments. Okay, we can do that. Let's stop the execution. So we can do it like this. Result plus equals 2. So result is now 3. What's wrong? Then it decrements, so that's minus equal and then 1. Oh, we can use the compound assignments. Yeah, let's do compound assignments. So like this. And then times equals 2. And then this. And then plus 8. And then modulo 7. Okay. Let's run this thing. And look at the results. So it should be 3, should be 2, should be 4, should be 2, should be 3. Okay. Expressions, statements, and blocks. This I know intuitively from other programming languages. This is an expression is a construct made up of variables, operators, method invocations, which are constructed according to the syntax of the language that evaluates to a single value. So this would be one, this would be another, this would be another, this would be another. This would be another. This. And this. 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 Not ambiguous by using parentheses. Statements. Sentences in natural languages. Complete unit of execution. By terminating the expression with a semicolon. So assignment, semicolon. Post increment, semicolon. Method invocation, semicolon. New, semicolon. Declaration and initialization. Control flow statements. And then there's blocks, 0 or more statements between pairs of curly brackets. So there's this block on the else, this block on the else, but you could have block inside the block, inside the block, inside block. Okay. Operators may be used in building arithmetic, in building expressions. Expressions are the core components of statements. Okay, let's skip over this. Next, control flow statements. So we have two groups. So we have linear structures, we do structure programming. Linear structure, alternative structures, that's if and switch, and repetitive structures for while and do while. And we exit with break, continue, or return. Okay. If then is if condition, so this should be evaluatable to a Boolean type and must be enclosed in parentheses. And then this is the body of the then branch. You might omit the pair of parentheses, and I never do such a thing. If then else contains a condition, then block and else block, and you can chain them if else, if else, if else, and then at the end there's a final else. Okay. Switch works at least by a variable of type int. Okay, it assigns to the month string local variable of type string the name of the month in English. These breaks are important. Otherwise, after executing this, if there's no break in here, also this will be executed. If there's no break in here, this will be executed. If a break exists, then it will exit. So for the month 1, it will return March instead of January. There's also a default case for the switch where we say that it's an invalid month. So month 0 is invalid month. Okay, you could have also used a ton of if-else ifs. Okay. In here, there's case without breaks. So, or if the month is 1, then this will be executed, this will be executed, this will be, all of these will be executed, and it will only break at 12. So a Java util array list of type string, which is a generic container, an array of strings, will contain for the month of January all of the 12 months. I don't really use switches. I don't think I have ever used. Let's skip over these things. So in here it says that in Java 7 you can now also use the string type for case. So there's an important method for the string type, which is called string.equals. Okay. If you want to do a lowercase equality, what you do, you first make one of the operands lowercase, and then the other one will be lowercase as well. And then you can compare equality, string equality. So there's a method called toLowerCase, which is not static method of the string object. Okay, so those were the alternative structures. We knew the linear structure, now we did the alternative structure, now we do the loops or the repetitive structures. While statement is true, while expression is true, keep executing statement. So we have count equals 1, count less than 11, it prints 1, and then it increments to 2. 2 is less than 11, will print 2. When count will be 10, will be less than 11, will print 10. Then count will become 11. 11 is not less than 11. It will jump out of the while in here. So what this actually prints is the numbers 1 to 10, including 1 and 10. While true, be really sure what you're doing, because this might be an infinite loop which consumes a ton of CPU computation and will spin your fans like crazy and hit your laptop and consume a ton of CPU and power. Okay, so this was while the condition is true, do the statement. And now this is the opposite, is do the statement while the condition is true. So this is called repeat. This is called while, and this is called repeat. So it says do statement while expressions. Okay. I'm not sure I have used repeat 3 times in my entire life. Okay. For the for has between round parentheses 3 things, and they're separated with semicolons. So you go initialization, termination, increment, and then statements in the body, in the block, in the body of the for. So the initialization could be int I equals 1, the termination might be I less than 11, and increment might be I plus plus. Okay. Infinite loop leaves out initialization, then puts a semicolon. Leaves out termination, puts a semicolon, leaves out increment. Don't do infinite loops. Okay. In here we declare an array of type int32, 10 positions. In the cells we have the integers from 1 to 10. And we do for each item of type int32 in numbers, so it will start with value 1, it will print, will arrive at value 10, it will print, and then it will exit the for each. Break statement, when you're searching for something in an array, you do a for each, for instance. When you found it, you go break. You say, I'm trying to find 8. So is this 8? No. Is this 8? No, 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 no. This is 8, yes. Then it's useless for me to try to find it here and here. Let's bail out. So break actually exits the for. If there's 4 in 4 in 4 and just one break, it will exit just the innermost 4. Like in here it's 4, 4, and then if this break says break search, and I don't know what break search is. Yeah, this is a label, so don't do labels, don't do go-tos. That's not structured programming. Continue is let's not execute the rest of the instructions in the body of the for. So this is the body of the for. When this instruction is executed, this line will not be 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 executed. So execution will jump straight here. We'll increment and evaluate if it's still, it should loop one more time, and then it evaluates the body of the for. Don't do labels. Return statement, if you have a method that has other types, return types than void, then you can use return with a value. If your method has return type void, then you can return early using this source code. So return semicolon. Summary of control flow statements. The most basic control flow statement supported by the Java programming language is the if. Any number of possible execution paths. Infinite loop with for, you just go around parentheses and then 2 semicolons, close the opened parentheses. Infinite loop, you go while and the condition is true. Classes and objects. So class is a type, object is when you go new and then the name of the type. Nested classes, you can have a class declared in another class. You have anonymous inner classes inside of the body of a method. There's lambda expressions, enumerations, enums. So a class has storage, has a CTOR, a constructor, and then it has 4 public methods. And then we have a mountain bike which extends bicycle, so it inherits all of these things except the constructor. And then you need a constructor, and you're going to call the constructor of the parent class that you're inheriting from, so bicycle, which is super, which calls this thing. So it requires 3 parameters: cadence, speed, and gear, this thing. And then these state fields will be initialized by this constructor. And since mountain bike has just 1 extra state field, you can just initialize that. And then add a method on top of the storage that's specific just for the mountain bike class. Declaring classes. So class my class, field constructor method declarations. Class extends my superclass. This can be only 1, whereas implements can be many. Okay, there's the modifiers, no modifier, like this, which makes it package visible. Then there's the modifier public, which exports this class from outside of this package, or private, which applies for class members, so field constructor and method declarations. So those will be available just inside of the body of the class, so just inside of this pair of curly brackets. If you want a class to be private class, then this class needs to be inside of the body of a class, so nested classes. So all identifiers until now have been Java casing, so start with a lowercase, whereas class names start with an initial letter capitalized. So the same as Java capitalization, but the first letter is not lowercase, it's uppercase. So this is called, I call it Pascal casing. A class can only extend subclass one parent, so there's no possibility of inheriting from two classes. The list of interfaces that we implement needs to be comma separated. Class can implement more than one interface. You can have empty body if you want. Member variables might be public. 0 or more modifiers, there's public, private. Okay. The fields type and then the fields name. Access modifier, public, accessible from all classes, private, accessible only within this pair of curly brackets, so inside the body of the class. It is common to make fields private. In order to access them, we create accessors, so public methods that might read or write these fields, the private ones. So get cadence, this is the classic way to do a getter accessor. So get and then the name of the field, and it just returns the value of the field, and set and then the name of the field. This is the setter method. It sets the value of the field to the value of the parameter. So there's one setter getter, and this only has getter and incrementors, decrementors. All variables must have a type. There's primitive types or reference types, string, array, or object. There's no structs, no enums. Who knows? Variable names. We use that naming rule with a Java casing, so lowercase first. Class names have the first letter capitalized. And for methods, it's preferred if the first word is a verb, so do something, is something, whatever not. Increment something, get something, set something. Public return type, identify, whatever, name of the function of the method, then list of arguments, parameters, then body. You can have an empty body, an empty list of arguments. There's public and private. If you don't want to return a value, you can use void. Parameters list is comma separated. An exceptions list, I don't really use this thing. Okay, so it doesn't really matter what is the name of the parameters. The name of the parameters are not part of the signature in the sense that you cannot declare this function, this method, and then this method again, but with different names for the parameters. Because it will say you already have a method that returns double and has 4 parameters, the first one being double, the second int, and the last two double. So the signature really is about types, not about parameter names. Run fast get background compared to set x is empty. So you can have is. And is methods generally return Boolean type. Okay, for method names use Java casing, similar to local variables. You can have more than one method with the same name, but then the list of types of the types of the parameters should be different. Okay, so this is string, this is int, this is double, this is int and double. So if it's 2 parameters, then that's different from 1 parameter. If it's 1 parameter, then what's the actual type? The argument. Okay. Constructors don't have a return type, have the same name as the name of the class. You can go new bicycle and then you give it 3 integers and it will pre-populate its state. New allocates memory. This allocates memory. This goes through here and initializes the member variables. This returns a reference. A reference is an, I don't know, an int or something. And then that int gets assigned in here. Now this reference is stored in here. You could create a default no argument construct or a no argument constructor and there initialize the state with to whatever you want, but you don't really need to because your state is already initialized. So in here, when you declare the state, you could already put the correct values that are most often used or something. This because it's a class. So if cadence is usually 10, you can have the best values for your state predefined in here, where you declare the member fields, and this way you will not need another constructor without arguments. Okay, so this has 3 arguments, this has 0 arguments, so they are different. So they're overloads. The compiler automatically provides a no argument default constructor for any class without constructors, as we have seen. So when we compiled a bicycle class to a Java bytecode, and then we decompiled it, we saw that there was a constructor called bicycle with 0 parameters and with empty body. So this is it. The compiler provides automatically a no argument default constructor for any class without constructors. And calls the no argument constructor of the superclass. Oh, interesting. Okay, you can use the superclass constructor, which we did in mountain bike, where we went super. Okay, and the usual trick for creating singletons is to make all of the constructors private. So people will need to use a factory or the singleton accessor in order to get to the reference to the class, because otherwise you cannot construct it from outside the class itself. You can return, so you go return and then a value which is of type double, and the method returns type double. Parameters refers to a list of variables in a method declaration. So this thing. Arguments are the actual values that are passed when the method is invoked. The list of arguments must match the declaration's parameters in type and order. Okay. You can use reference types, objects, arrays. Arbitrary number of arguments is with a three dots operator. Was this ellipsis? So this must be the last parameter. You write its type and then you put three dots, and then you give the name of the parameter. So you could call this method with 1 point, with 2 points, with 7 points. Okay, and the print function is the definition of functions with a arbitrary number of arguments. So this is called the mask or the format, and then these are the arguments to the format. So if we have 3 placeholders in here, then we need 3 arguments. If we have 5 placeholders, then we need 5 arguments, and %n seems to be the new line terminator. Okay. So in order to call a method that expects an int, you just say int and then p in the list of parameters. If you have a signature that has a parameter of type class, of type object, then this will be passed by reference, because circle is a reference. So in here we'll enter a reference, and then when you do circle set x, circle set y, circle equals new, you're actually affecting that reference. So reference types are passed by value, but it's the value of the reference. So passed by value of reference. Okay. Okay, so garbage collection. If a thing that's allocated using new has 0 references pointing to it, then that thing occupies RAM needlessly and it will be garbage collected at some time, at some point. So we go origin 1 point and origin 1 here. So we have 2 references to this new thing. And then we go rect to move. Okay, so we create objects using the new keyword that allocates memory on the RAM depending on the size of the object, and it calls a constructor, could be the default argumentless provided by the framework, by Java, or could be one written by us. Okay, so it creates a point, then this reference is passed here to create a rectangle, and then it creates a rectangle without any points. Declaration, instantiation, and initialization. So declaration is type followed by a variable declaration. There's the assignment, new, and the call to the constructor. You could separate those, like do just the declaration, nothing else. So type, space, variable name, and then semicolon. Or you could go in one go, type, variable name equals, and then you call constructor. Okay, this is called a temporary. You might not use such a thing, so you go new rectangle, this allocates an object, it returns a ref, and that reference is an object, and you immediately call a method of it, and then since this thing is not accessible from anywhere, there's 0 references to this new thing, so it will be garbage collected at some point. Constructors. So this is the point object x and y, and there's origin 1, which holds just one reference to the thing that's allocated using new. Rectangle for constructors, no parameters, 1 point, 2 ints, point and 2 ints, and move and get area. So this is a reference from origin 1 to the point, and then this thing is being passed to the constructor in here. So now there's to this thing which was allocated using new, there's the reference origin 1, which is the line above, and now there's also the reference inside of the rectangle object. Might be stored or not there. Might have been just used inside of the constructor to get at its x and y, and then the reference might be the reference count might have been decreased by not using origin 1 outside of the constructor. Okay. A class's own fields can be accessed either with just the name of the field, or you can go this dot with the members. If they're public of another object, you go object name dot field name, so rect1 dot with, or you can go new rectangle dot height, call the object's method, so object dot method name argument list. Out is such an reference, and you call its print line method, or rect2 and call the method move, or you create a object and immediately call get area, and then the reference to this new thing is going to be lost and will be garbage collected. This will also be garbage collected after the semicolon is executed. The garbage collector. Okay, so the Java source code contains a ton of new. So you keep allocating things on the RAM, on the random access, in the random access memory, but you don't really have places in your Java source code when you deallocate things. So somebody needs to deallocate all of these objects that live just in this source code line, and other objects that stop having references to it. So they have a reference count of 0. And that thing is an automated infrastructure inside of the Java Virtual Machine JVM, which is called the garbage collector. There's many types of garbage collectors with all sorts of interesting trade-offs. Okay. After all of the lines inside of the body of the method are executed, the control will be passed back to the caller of that method. Or if you have a return statement, then the rest of the lines in the method will not be executed and control will be passed back to the caller of the method. Or if you throw an exception, whichever occurs first. Methods declare with void do not return a value. You might have return with no arguments. If the method returns something else than void, then you must have return space and then a value that will be returned by the method. So if you have a method getArea that returns int, before the execution of the body finishes, you must call return with an int value. Otherwise, this is probably a compiler error. You can return reference types. So you can return references. If you say that your method returns a class, you create an instance inside and then you return that instance. So in here, if you go new something new, you go bicycle space fastest equals new of bicycle, then a new thing will be allocated. A ref will be created to it and assigned to fastest. When you say return fastest, fastest will die, so its reference will disappear. But then a new reference will be created and given to the caller of see who's fastest, such that the bicycle local object that's defined in here doesn't get collected by the garbage collector. Object number, imaginary number. This java.lang.number. Covariant return type. So inheriting classes is not something I do. Using the this keyword allows you to disambiguate, and I use it always. Whenever possible, I use the this keyword. So this could have been this.x, and this could have been this.y, because x and y are member variables. Whereas x and y, this without this, so this and this and this and this are actual arguments, parameters. Okay, you can call a constructor from another constructor. I use this when I do primary constructors. So one of the constructors has the most number of parameters. That constructor I name the primary constructor, and then all of the other constructors don't do anything else but call the primary constructor, and if needed, so if you receive two parameters, you pass them to the primary constructor, and then for the other parameters you pass whatever values are appropriate. Okay, this way you have logic, constructor logic in just one place. You don't need to duplicate these computations or something in all of your constructors. So no explicit modifier means package private or package visibility, and public is exits the package, can be used from other packages. Okay, and members could be public, private, protected without any modifier. It's again package visibility. Okay. Choosing the access level. So choosing the access level is simple. All members should be public, otherwise you're hiding a class in another class. And visibility for classes by default should be package, not public. So you only export from the package what's really necessary. Avoid public fields Well, that's what you say. That's not what I say. Use the most restrictive access level that makes sense for a particular member. No way. No way. You want your members to be small, so you want a class to have a small number of methods, a small number of source code lines, a small number of source code lines in each method, or most methods should be public, and you want to test most of your members, most of your classes and most of your methods. In order to be able to test them, you need to have them either package visibility if the tests are inside of the same package, the XUnit tests, the test drivers, or make them public if the tests are in other package. Okay. So the things that are not object members but class members use the keyword static. Might be static fields or class variables, or might be static methods. Private static int number of bicycles. Okay. Class methods, if you don't want to go to use a new keyword, you just put the name of the class and then dot method name. This is normal for alternatives to the constructor, so for factory methods or makers, or what you call that thing. For instantiators. Okay, constants, static, final, double pi, and then a number, and this thing is double because double is default if you don't have a suffix. You need the suffix f if it's a float point, a float type, not a double type. Okay, bicycle class, get number of bicycles, and the constructor increments the number of bicycles. Initializing fields. You can initialize them. They're initialized to zeros. Static initialization blocks. These are, I don't know, outside of, where are these? Initializer blocks for instance variables look just like static initializer blocks, but without a static keyword. I do not know what that thing is. Creating and using classes and objects. So this is the name of the qualified name of an instance. So this is object and then dot variable. Object dot method. This calls the method, and then object method name. All unused objects that were allocated using new and don't have any references pointing to them might be garbage collected. We do not know when or if. Okay. You can explicitly drop a reference by setting the variable holding the reference to null. Okay, what else? So rectangle, my rect, then void width and height. and then you say the area is myrect.area. And we need to go back to find out what's the source code for the rectangle class. Okay, next. Nested classes, so you can go class and inside you have another class, etc. And you can have another static class. And this can be even visibility private. Creates encapsulation. Okay, might. Outer class dot inner class, and then you instantiate it if it's visible outside of the outer class. So if it's like this, package, visibility, or public. Okay, and then there's the other thing, which is a anonymous class. Don't do shadowing. Use this. Serialization of inner classes, including local and anonymous classes, is strongly discouraged. Synthetic constructs, these are classing methods and other constructs, do not have a corresponding construct in the source code. I know. Okay, next. Inner class example. Even iterator inner class. Where is that thing? Private class even iterator implements data structure iterator. Oh, what's here? Okay, so it's nested into another class, so it can be private. Okay, and then within the body of a method, you can declare an inner class. Local classes. And you can declare it without even a class name, so that's an anonymous class. Okay, next. Local classes. So inside of a method, you go class and then name, and then you declare the class. Or even more. Anonymous class is where you go inside of the method, you define a class, but you don't specify its name. Where are you? So it says class, but it doesn't say its name inside of a body of a method. Yeah. No? What? So you say new of hello world, and then you give it a body. This thing. So you say new of interface, and then you give it a class source code. So the source code for the entire class, but then you do not know its name. Whereas in here you give it a name. So you go class name implements hello world, and then you give it a body. In here you say hello world. You say implements hello world, no name, it clearly is a class, and this thing, which is the body, is given like this with a semicolon at the end. Okay, so it's used for event handler because there's no events. So in C# there exists events, there's keywords for them, and in Java there's no such thing as GUI event handlers and events. Okay, next, lambda expressions. This is not beginner material, so we'll just jump over it. Lambda and lambda. Generics. GUI applications. Okay. Method references. How do you do a method reference? This thing, roster array, no? Oh, these things. Okay, let's ignore lambdas and associated things. Functional and capture and stuff like that. Nested classes. We'll ignore it. It's way too advanced. I have never used such a thing. I did. An enum type. Okay, so your public enum type name and then possible values. You can use it in switches. It uses, I don't know, snake casing or something. They're kind of limited. You can't easily get the string value of this, so you can't easily get to the string uppercase Sunday. You cannot easily say that Sunday has index 0 or index 20 and then get its index back. Okay. You cannot easily do flags and start indexes from something else than 0 and say that it's not int but unsigned long or something. An enum type can be a subclass of Java long string. What? No, it cannot. Implicitly extend Java long enum. And this is a real class, and string is a real class, so you cannot have multiple inheritance from multiple classes. Okay, interesting. Annotations. Okay. So the @ sign and then something. You can put them above a method. Above a class. You can use more than one. You can do aspect-oriented programming, AOP. Okay. Predefined annotations, deprecated, very useful. Override. What's repeatable? Not null. Annotate element get annotation of class T. Okay. Interfaces and inheritance. Public interface. A bunch of signatures of methods. Then public class implements operate car. Could be thought as API. An interface can extend other interfaces. Interface body can contain abstract methods, default methods, and static methods. Whoa. Implementing an interface. Class implements interface. Yeah, we saw that. Using an interface as a type. So you can cast an object to a type, and then you can compare the two is larger than using the relatable interface. Is larger than. You add another method to the interface. All classes that implement the old will break. Try to anticipate all uses for your interface and specify it completely from the beginning. You can create a second interface, do it plus or do it X or do it 2 or something. Okay, this is ABI talk. Pretty advanced things. Default methods, no, let's not go there. Okay, next. Inheritance, didn't we talk mega much about inheritance, even though I never use inheritance? Yeah. Multiple inheritance of state, why would you do such a thing? Overriding and hiding, there's at override annotation. Next, polymorphism, let's not go there. Hiding fields, super print method, wow, that sounds like good design. You're hiding the method from the parent class, so now you need to go to super to access the method of the parent. Subclass constructors, you call the parent constructor. The hashcode method. There's a method, objects hashcode, integer value generated by a hashing algorithm. What are these? These are interesting. Okay. So there's inside of the package java.lang a class named object that most objects derive from, or all implement. Every class is a descendant, direct or indirect of object. Every class you use or write inherits the instance methods of object. You need not use any of these methods. You may need to override them to make them specific to your class. So there's clone equals hashcode, which goes hand in hand with equals, and then toString. Finalize, called by the garbage collector when garbage collector determines that there are no more references to this object, so probably for deallocating non-managed resources or something. Notify all and wait. These are for synchronization, so wait for multiple objects or something. The equivalent in the Win32 API. Wait how much? Nanoseconds. Clone implements clonable interface. Create a deep copy of an existing object. The method throws clone not support exception. Okay, next, equals, really often used, compares that two objects are equal, returns true if they are equal. Object uses the identity operator. For primitive data types, identity operators works correctly. For objects, it does not. The equal method provided by object tests whether the object references are equal. So if you have two car objects with the exact same data members, they are different because they are allocated in different places in the RAM. To test whether two objects are equal in the sense that they have the same state, then you must go override the equals method and do something like, I don't know, serialize both objects and then compare the string, or serialize them, for instance, to JSON and then compare, or compare each of the data members, public data members. Okay. Finalize. May be called. It's uncertain. Don't rely to do cleanup. Okay, so this is classic thing when you don't need unmanaged resources. Immediately remove them. Don't wait for the garbage collector to do your thing. Try with resources statement. Okay. Get class. Turns the class object. Has a large number of methods. Okay. Hash code. If two objects are equal, in the sense that the method equals returns true, even if they point to even if they're allocated into different places in RAM, their hash code must be also equal. So whenever you override equals, you also need to override the hash code method. Okay, and toString, if you don't like whatever object does, which is show the name of the type, when you go object toString, you will need to override toString in your class definition. Okay, next. Final classes and the methods. Let's skip over this. Abstract methods and classes. Let's skip over this. So this is not a tutorial, this is a deep language reference. Numbers and strings. There's a number class in java.lang. There's a print stream and decimal format. There's a math. There's boxing. There's for the primitive types a twin class, which is a class inside of the Java API with class capitalization, so Pascal casing, uppercase B, Y, T, E, for the byte type, the byte primitive type. Byte value, short value, int value, long value, float value. Compare to integer. Parse int to string. Formatting numeric print output. System out format. %f, %s, %d. Okay, what else? D decimal, F float, new line. Never use \n, I don't know why. Decimal format class. I don't know what this thing does. Math.cos, let's not go there. Let's ignore the math types and methods. Arctangent, don't go there. Random numbers. There's a math.random, which returns between 0.0 and 0.1. Multiply that and you convert to int. Okay. Next. Characters. So this is a character, 2 bytes. A char array. There's a character with uppercase C. Which is a boxer for the char type. Is letter, is digit, is white space. \t, \b, \n, r, f. Don't use this. Okay. Strings. The type uppercase S, tr, en, g. You allocate it like this. Char array, new string of char array. Print line of string. String.length. Okay. String concat. Literal.concat. Literal plus literal. Print statements. Format strings %f. Converting strings to numbers. So you use the box classes because those have a method value of and float value. Numbers to strings. Integer to string, double to string. Okay. Characters in a string. Who the heck knows how to manipulate characters in a string because of UTF and Unicode. So let's not go there. I've never needed to do such a thing. There's last index of, there's substring, but how do these things work on a Chinese string? Index of, last index of, to uppercase trim, to lowercase, split by regex, substring, string manipulation. Next. Ends with starts with compare to ignore case equals. How do you pass it a culture? Region matches. String builder, instead of using string concatenation, so the plus operator for strings, you might want to use string builder. Append. You usually just do append and then you at the very end you go to string. Okay. Characters as strings. So the string class has 60 methods, 13 constructors. There is a character class, to uppercase value of split to lowercase, string builder reverse to string auto boxing like this, generics, integer boxed, boxers, let's keep the generics, way too advanced, row types. What is that row type? Box of integer. Generic class or interface without any type arguments. I don't know what you're doing there. Generic methods. Bounded type parameters. Public queue extends number. Multiple bounds. Where are we now? Okay, packages. What's the package? How to bundle classes and interfaces into packages. How to use classes that are in packages. How to arrange your file system such that the compiler can find your source files. Okay, we use packages. Grouping of classes, interfaces, enumerations, annotations, etc. The important part being that if you don't provide any visibility keywords, or you don't go public on your classes, those have default package visibility. Okay. So we have draggable Java, just one interface, just one file, just one class graphic, just one file graphic.java, just one class circle, just one Java file. So each class or interface or type in general is in own .java file. So this way we know that all of these classes are related. We know where to find them. You do not have conflicts because you're using a namespace. And they can see each other and their tests. Creating a package. You choose the name for a package. You put package statement and then the name at the top of every source file. Package graphics, semicolon. Must be the first line in the source file. Can be only one package statement in each file. If you put multiple types in a single file, only one can be public, and it must have the same name as the source file. Yes. You can include non-public types in the same file as a public type. This is strongly discouraged unless the non-public types are small and closely related to the public type. But only the public type will be accessible from outside of the package, yes. All the top level non-public types will be package private, yes. If you put the graphics, interface and classes, you need 6 source files. If you do not use a package statement, your type ends up in an unnamed package. An unnamed package is only for smaller temporary applications or when you are just beginning the development process. Class and interfaces belong in named packages. Okay, so always use the package. Naming a package, you could use reverse DNS. Don't use things that are already namespaces that exist in the first party. So namespaces that already exist in the JDK, or don't start your namespace with a string that already is part of the name of a package in the JDK. So don't go java dot something. That's not your namespace to use. Okay, so you can use this thing. You cannot use minus. Int is not legal because it's a keyword. You cannot start with a digit. You must start with underscore or A to Z. Package members. The types that comprise a package are known as package members. Either you refer to it by its fully qualified name, so reverse DNS name and then dot class name, or import a package member, or import the entire package. So you can go graphics.rectangle, import graphics.rectangle, or import graphics.asterisk. Okay, hierarchy. Packages are not hierarchical. Java.auth.color is not included in java.auth. Okay, so it shows relationship, not inclusion. Interesting. Does not import java.awt.asterisk, does not import java.awt.color. Okay, just the classes or the types inside of this package, not other packages. Because there's no such thing as subpackages. There's a java.auth.rectangle and there's a graphics.rectangle. So you'll need to disambiguate. Static import. This is usually used for print line and math functions. So you go import static and then the name of a static member, a static method. Or you can import all of the static methods of a class. Next. Most IDEs help you or force you to use correct directory structure for your packages. So for graphics, there should be a directory graphics, and then you have your source code files in there. This is the package graphics. Com example graphics. Okay. Class path environment variable. You can see if it exists. You can clean it up. Or you can set it to some value. Fully qualified name of type, import the type, import the entire package. End of trail for essential for learning the Java language. The next one is essential Java classes.